everyone. Thank you for joining in and good afternoon. We still have a lot of people joining in. I can see a lot of people trickling in because we are starting bang at 12 p.m. So let's give everyone a few seconds to join in, and then we are going to start our Launchpad. But to people who have joined in, welcome and great to have you all. Yes. Hi, Sudeep. Hi, Nisar. Hi, Anil. Hi, everyone. Hi, Rajan. Hey, Rahul. I still have like a lot of people coming in. I'm going to give it a few seconds. Till then, I'm going to introduce myself. Welcome everyone. I am Niyati from Interview Kickstart. I'm going to be your host and your moderator for today's two sessions. And we also have a speaker, of course, who will be joining in. And she has already joined in. Nahid is already in the room. And I'm going to introduce her shortly, but I want to introduce to you guys our AI Launchpad as well as Interview Kickstart. A lot of you know who we are, know what we do, but for a lot of you, we are still, new. So I'm going to take this opportunity to introduce ourselves and this. What are we going to do in the next 2 days, today and tomorrow? Firstly, can you hear me clearly? Can you see my screen? Can you just in the chat say hi or something like that? So you can see my screen also and you can hear me also. Hi. Hi, everyone. Thanks for saying hi. Yes, awesome. Okay, I got a lot of replies. So I'm going to start. And I can see a lot of people have also joined in. So thanks a lot. I think it's a good time to start now. Now, what are we here to do? So we are here for the next 2 days, today and tomorrow, take you from foundations of agentic AI to help you see how once you build an agent using MCP, how does it go to production and deployment. While this is not a follow along session, you'll see experts do it. And we live stream all of our sessions. So you can come back and you can go through the sessions on your own at your own pace and then do it, follow along with the recording. But this is the agenda for the next 2 days. So today's two sessions are going to be, first is foundation. So very important what we have. This is our fifth edition of doing this. We do this once in a month. We pick up a weekend. We call all of you. And somebody who wants to set up by the end of 2 days an AI pilot, this is a perfect launch pad for you, right? So in the first session, we are going to, that's why I start with the basics. It would be conceptual because it is important. Most of you are from tech background, and these sessions are very useful for you if you are from a tech background. If you are from a non-tech background, maybe stay along, try to follow along and see how much can you grasp. So we'll start with the basics, and then in the next session, which is today itself, we are going to touch upon the agents, building the first agent with MCP, right? Day two, which is going to be taken over and moderated and hosted by my colleague Moin. He'll join you guys tomorrow. You're going to orchestrate multiple agents working together and see how do you take like a toy demo to sort of production, right? So this is what we are doing. We are also towards the end of every day. That means every day second session. We are going to spend like half an hour, 40 minutes talking about how agentic AI questions are being asked in interviews. Okay, so that's a little bit of a something to look forward to for all of you, because while you'll build all of this, how to answer those questions in the interview also becomes primary. I'm just going to check my chat again in case is there any issue in my screen or audio. Okay, everything is clear. Cool. Uh, so we have a community on Slack and Discord, which the links I'll share in a while, as soon as I stop presenting and I hand it over to the speaker for today, where we keep sharing some free tools and resources, whatever material that can help you take off this AI Launchpad journey, right? So the day one guide and the day two playbook is in front of you, and we'll be sharing this with you. So don't worry. We'll be sharing the links in the Discord and Slack community. Just make sure you join them so that you can keep getting such free resources whenever we post them. Right. Who is this Launchpad for? Like I think I touched upon this a couple of minutes back. Particularly useful for engineers, for tech product managers, for TPMs, technical program managers, EMs. So anybody who is wanting to take like a quick crash course of sorts in these 2 days and understand the agentic AI concepts and start building an agent, this is something this particular 2 days are for you. Okay, so now quickly about IK, and I'm going to hand it over to Nahid then. We have been doing this for over 11 years. We started in the Silicon Valley in the US, and in India, we came about 2 to 3 years back. We are obsessed with the journeys of technical professionals, and we don't observe all of you guys as one technical professional. We know that a journey of a backend engineer or a TPM or an EM who's engineering leader is very very different, or a product manager or a data scientist is very different. So we actually customize our AI ML programs as well as interview prep programs for these many domains. Our secret sauce is our Mang Plus instructors who in the day job they would be scaling and building AI systems in in companies like Meta, Amazon, Apple, Netflix, Google, Microsoft, all of these. And then over the weekend, they teach you how to build this yourself, right? So uh, it's actually, as the saying goes, from the horse's mouth. So that's what we follow here, and that's our secret sauce. So all of our instructors are actual AI practitioners. We have a base of about 27,000 alum across India and the US. You can see some of the successes that our learners have seen in terms of remuneration and compensation. That's there in front of your screen. All of our instructors, on an average, have more than a decade, 13 plus years of experience. So this is the secret sauce I was talking about. You'll also get a little bit of insight when you'll see different instructors who are coming in this particular launchpad and taking you through the concepts. You'll understand the quality of our instructors also. So without further ado, I'll introduce Nahid. Hi, Nahid. I know you've already joined in. Thanks for joining in early. Nahid is a principal software EM at Microsoft. She's had a very decorated journey. As you can see, she has worked with Google, Capital One, Accenture, all the big names out there. She's also a PhD in computer engineering from Virginia Tech, and she has over 10 years of experience. She is currently building and scaling agentic AI frameworks and systems. And I cannot think of a better host who can take you through the first session, which is the foundation session for today. So over to you, Nahid. And while I'm handing it over to you, I'm going to just mention that I'm going to be launching a poll to understand where you are in your current journey. This is for all the audience, so that whatever we deliver, we know it is relevant for you, or how can we get better and all of that, right? So enjoy the session, guys. Thank you.
All right. Hi everyone. Welcome to the session. I'm very excited to see the crowd. Hopefully everyone can hear me and they can see me.
Yes.
And let's get started. This is our agenda for today. We're going to cover, why AI. It's very, the foundation and the preliminary requirements here. Um, and I'm then going to talk about RAG, chunking and embedding, and we'll get to prompt engineering and agents, and then some agent development framework, and then we will have a small demo, a coding demo of a working agent using LangChain. Let's start, with, why AI and why now. Basically, generative AI essentially has moved, like a crazy movement over the past couple of years since 2022, basically. It all started with a paper named Attention is All You Need, which was developed by Google DeepMind researchers. So we basically owe all of we have to those researchers and basically to every researcher who has expanded this field. So yeah, the G in ChatGPT stands for generative pre-trained transformer, and that is basically transformer is the basis of all the, the papers, all the different LLMs, large language models that we will see out there. And the paper has been around for like 9, 10 years now. So you can see how fast we are moving from something that was just theory to a lot of tools and now agentic AI. So a lot of progress has been made in the past, few years, and as a result of it, the adoption of these tools also is becoming very important in almost all companies, even non-tech companies, and in non-technical roles. Everyone is required to leverage AI-based tools to improve their work, their impact, accelerate the processes, automate the processes, and so you can see the numbers actually. There has been more than like 50% growth in AI adoption, specifically like generative AI adoption. So maybe we should just say like why not? This is the right time and the right moment to invest in this journey basically. And there are a lot of success stories here you can see in different products. There is Uber Genie, GitHub Copilot. For those of you who are a developer, I'm sure you are using VS Code, and GitHub Copilot is a huge enabler for coding. It's very efficient code assistant. Intuit is basically an tax filing financial company, tax management company, and they have uh, basically spent a lot of money on customer assistant, legal aid, etc. And now they have automated, all those work processes using agents. So you can see how, every company is trying to adopt and kind of like integrate this service into the agentic AI into their services. And I cannot also like begin to expand on the AI's impact on all of these, jobs and skills and how it help everyone. So before, kind of like before trying to scare everyone, there is literally no need to be afraid. I think we are in a good place. It has displaced some jobs, but it also has created a lot of new roles, and so the task responsibilities are different, the expectations are different. So some jobs are displaced, but there are roles like AI engineers, or I see a lot of, for example, Google roles, forward deployment engineer, customer solution engineer, that are about to support generative AI. So there's there may be like significant opportunities here as well. And majority of developers use AI, product managers are using AI. So basically, if you are, a marketing or salesperson, you need to know how to use agents for this kind of role. So AI adoption is kind of like going to become more and more prominent in everyday job. And so the idea is not to kind of like be left behind. We want to address this innovation gap, and we want to make sure that everyone, is benefiting from this great innovation here. So let's start with actually what is generative AI. Um, and so typically, maybe 15 years ago, we would basically talk about artificial intelligence, and artificial intelligence, was this broad umbrella where you use data to create predictions. And then, we had predictive algorithms learned based on some data, some patterns to make prediction. And basically, those fall under the umbrella of artificial intelligence. And within artificial intelligence, there were subdomains. One of them was deep learning, the other one was natural language processing, which we used to, deal with text data. We had computer vision, or, signal processing, etc. Dealing with, structuring neural network and learning and creating complex architectures, from the data. But again, all of those were under AI. And so in the last few years, we have this, new subdomain, which is called Gen AI. And what's different about generative AI than, the previous AI domains is that, it is basically the word generative. And what it really means is that you are using these models to not just, recreate information that it has learned from the training data, but you're also using these models to generate new information. So generative AI refers to the use of machine learning or AI tools to create new content that it has not seen in its training data. So you can think about, generating code or even like using it for debugging code. You can design, customer support frameworks or bots. You can do data analytics where these models can be used to offer new insights associated with your data. You can also have personalization. You can use language models or Gen AI models to personalize, your e-commerce experience, or for example, watching a movie experience. Netflix has a lot of, generative AI technology being integrated in their work. There's like, it's very vast. It can be multimodal data, image, video, text, audio. All of these different modalities can be input to your model, and you can also use these models then to create something new. So basically, we are in the generative AI bubble, and now, so this is what we are dealing with. So large language models, basically, let's define this. So the most common, use case that we have seen of generative AI is large language model. We have like a small language model or VLM. There are different models, but why large? Because they are, these huge neural network, large transformer architectures, which have billions of parameters. And so when you train these models with tons of data, you have, this really complex set of weights you need to store to make a prediction based on, this new text that is coming in. So that's why it's large language model, because it's dealing with language. It's trying to model human language. You can imagine English or other languages. And then the model is a mathematical framework. It still makes predictions, so that is why we call it large language model. And we see, the influential paper, which is Attention is All You Need, is basically what created transformer-based architecture. And transformer-based architecture enabled the building large language models here. So what does it do is that, given a set of sentences or context, it will predict, the next word or the next 1,000 words. So, and because of, that is just because of their ability and the way they are trained. So it comes, with some capabilities and limitations. They can be, used for grounding certain contexts. For example, given a certain text, it can figure out what the text is about. It can categorize that text. It can write product review summaries. You can imagine like Amazon. Or if you open, some reviews about a product, it can summarize it for you. So that's typically done with an LLM. You can, take all of the reviews and just use summarization with it. You can use LLMs for, Q&A, sentiment analysis. Is this a good movie? Is this a bad movie? So these are just some of the few capabilities. You can imagine it's a lot, and we all are basically using it nowadays. So these models are just still learning certain disruptions that they have seen in their training data set. So they operate within certain constraints as well, because they're only trained on certain types of the data. If you're going to expose them to a completely different, distribution of the data, they may hallucinate, and basically they can produce new information that seems very reasonable, but it is factually not true. So they have, they are vulnerable to producing these types of hallucination, misinformation, and these are very expensive models to train. They are expensive to run inference on, so you need, a certain amount of compute power to use LLMs, and then that is why, there's also like knowledge cutoff. So, for example, you remember GPT models starting from GPT 2 to 5.2 and 5.1. Each of these, they are trained based on certain amount of data up to a certain point in time. So there's a knowledge cutoff that, between different versions of the models. So yeah, and then there's also, company specific information. So given, that we have seen these capabilities and limitations, one question that we may ask is, how will we design, how will we, solve a problem? Let's say we want to design a system, that answers questions about company specific problems. So um, for example, if they don't have access to your proprietary data, then they're not going to, to create answers associated with your data. So how will you design an agent that tells you, let's say, healthcare information, legal information? That is our challenge. And the answer to that is called RAG, Retrieval Augmented Generation. And so this will basically enable us to answer the challenge. And so if you ask a very simple, GPT-2 type of model, I'm not talking about chat GPT, I'm just saying GPT. I'm asking like a pre-trained transformer model, which has no access to any tools, no access to internet. It was, imagine trained on some previous data. If I ask it like, what is, the weather like in, California, it will, learn that a very reasonable statement, and it will follow, English construction of the language, and a very reasonable output, something like whether it's sunny, like, I don't know, 70 degrees of Fahrenheit. And this is very reasonable construction, but it doesn't mean that it is like literally true and consistent to live data. The weather right now might be 40, right? It could be anything, but that is just something that the GPT model has learned to answer. This is what a simple LLM does. On the other hand, what we want right now is, we want an LLM to take an input and then find some relevant information. Let's say, this is your database of some proprietary documents, and we want the input to be first compared with what documents we already have in our database. If there is some information associated with that input in this document, we can, then retrieve those documents and then use all of that information to produce the output. So your keyword here should be retrieval, augmented generation. So not just blunt generation, but a generation that is using the retrieved information. So this is the high level idea behind RAG. And so LLMs, you can imagine them as a search engine, and RAG is an architecture that combines this understanding of LLMs with real-time access to some external knowledge. And this is how the external knowledge is given, to LLMs, where, we are, trying to draw a line here. For example, a user asks a question, and you compare the user's question to the, documents, and retrieve some of the top relevant pages, top relevant paragraphs from the documents, and you can take, user's query and all of that relevant information, pass all of it to the LLM, and then you can ask the LLM to create a response. So that's really your basic RAG pipeline. And a lot of things go into designing each of these different pieces. So how do you choose, for example, your vector database? How do you choose, chunks of the data? How do you break down, these documents into smaller parts? These are all, questions that we can answer in a couple of slides. So what are its benefits and why would, you use RAG as opposed to just throwing your question at an LLM? So some of the key benefits, that systems like RAG enable us are up-to-date answers. You can think about updating this, vector database with, imagine you want to, for example, summarize latest news that happened just yesterday, and you can basically keep updating your information on an hourly basis. So you will get, accuracy, you will get groundedness, and essentially you can instruct your system to answer only questions which are found in the documents. So that is basically the accuracy and groundedness. You can use smaller LLMs, but because you're giving them access to the external database, it's cheaper. So you have a small model with large amount of external knowledge available to it. So that's actually much better than a bigger model with no external access. So you can also do like domain adoption. Maybe your company is using some specific keywords. Maybe there's like acronyms that they're using. Maybe it's legal. Maybe it's healthcare. They have this different language. They have this different tone, and you can actually adjust your LLM to that terminology here. So, yeah, let's move to actually chunking. Yeah, basically, chunking means that AI cannot read, all of your information. But you need to basically start chunking it. AI doesn't read like humans. It needs help understanding the long text, long paragraph, and where chunking really comes into helping is basically breaking a big piece of text and breaking it down into smaller parts, and that's literally means chunking. And there are like different strategies associated with chunking. So there is like recursive chunking, there is paragraph based chunking, sentence based chunking, and each of these different types of chunking methods um, are useful for different use cases. For example, you can think about breaking down a piece of code in a different way. Let's say that you would break down a storybook or a novel. Maybe a storybook you would break down by page, but a piece of code, then if you want to break it down, you would break it down by modular functions. Maybe main.py file is one thing, and then the function is another chunk, something like this. So you have to keep in mind when you design a RAG type of system how you do chunking, and this is actually one of the good and debatable interview questions that you can learn as an outcome of this course and you can practice on. And then after you chunk the documents, you are going to store them in what we call a vector database. So we'll talk about why we need to store them in a vector database, because you cannot store these long pieces of text just anywhere, right? So you have to make sure that it is stored in a database where you can retrieve it later and get more information on it. There are different strategies for chunking. For example, we have fixed size. It's for uniform text, mostly for quick prototyping. We have paragraph. It's mostly for reporting, documentation. We even have like sentence based. It's for like imagine you have frequently asked questions. Hierarchical is for like legal documents or long manuals. Semantic is for unstructured text. So there's a lot of different strategies that we can have here. Now we get to another concept, which is embeddings. Embeddings let us capture the semantic meaning into, a vector representation. So it's very, mathematical. So let's first understand it intuitively. What embeddings, really do is that they imagine something like this. It is a very popular example, by the way. Imagine like we have king and man, and these are two vectors, and they have like a distance, and there's like an angle in between those two vectors. Uh, Similarly, we may have another vector for queen. So the vector for woman has the same distance from queen, similar to man from king. So if man maps to king, woman maps to queen. So the distance between the queen and woman is very small, similar to the distance between king and man. And because those words have semantic similarity, that embeddings are very strong, and what makes these LLMs be, really generate meaningful stuff for us. So yeah, so you can, for example, imagine talking about like mountain and then similar words that happen in mountain, how far apart, words related to that can be. So embedding models, are a type of, yet another type of pre-trained neural network models. And once you get the embeddings, you can store them in chunks, and you can, break down your document into, small pieces. So that's essentially, pieces of text. And then you are going to, take those pieces of text and convert them to vectors, and then you can store them in a vector database. So in a database, we couldn't just store like sentences, etc. How are we going to find them? How are we going to find, like, how are we going to know what they mean, etc., right? So that is what we need. We need to have embeddings to be able to get a set of vectors, and then those vectors will be stored in what we call a vector database. So yeah, embeddings matter because they enable you to find a text that means the same thing, not just, keyword matching. So you can imagine mountain related to hiking, related to hills, are grouped in one category, and then apples, bananas, mangoes, etc. are in the same category. So it can find, relevant information. They can capture meaning, and can let you capture relevant passages by mathematical operation. Literally, we have sine or cosine similarity distance measurement for similarity detection, because it's mathematic at this point. The vectors are numbers, so they let you do semantic search, meaning finding text that is similar. Because of semantic search, they let you perform context retrieval. So essentially, if a user, asks a question, you can search the vector database, and you can quickly, get back the answer or all the context. So because of, that, it enables personalization, and then, it applies this mathematical transformation to your text. So then text into a vector representation, and because you have converted the text into a vector representation, it allows you to efficiently, find the most similar text here. So that is really, enabling. You can find similar concepts here. Um, and so it can, and it can have really high dimensions. So which means it is, it's very strong, so very powerful. So uh, I'm going to, yeah, read some of the questions. There are questions about the embeddings. um, yeah, thank you for the explanation of embedding vectors. Vector DB, even though we have so many, vector DBs actually are stored in, same DBs. So we don't have to yet learn another, a set of DB. It's just that knowing what type of information we are storing is what matters. Um, yeah. Um, how does embeddings arrive at similar vector representations for king and man and queen and woman? Basically, it's a number numerical representation. As I said, it's similar like to a deep learning or neural network architecture. It is trained by so many data based on their context, and they end up basically, it's like training a model. So finding similar words in, different texts that are close to each other will get very close numerical representation. Uh, um, all right. So, yeah. Oh, this is also interesting. So after you get the embeddings, they are numbers, right? So you can map them into different, space, and what you will see is very interesting. You will see, there's like semantic proximity. Similar concepts are very close in the vector space to each other. And then there are like some distant concepts, like for example, microscope is far away from ocean, imagine, or cat and dog and other animals are very close to each other versus another cluster that is related to let's say ocean or water. And so as a result, we usually measure the distance. Measuring distance between text is very difficult, but once we have numbers, it's very easy. We can think of Euclidean distance, we can think of like cosine similarity. Then when it becomes numbers, processing everything will be much much easier here. Okay, so now let's go back to vector databases. We had a bunch of documents. We broke those documents down into smaller pieces, and then we converted them into chunks, and then let's say we converted some English words into vector representation. And once we have these embeddings, the next thing that we can do with those embeddings associated with chunks is store them somewhere, right? So, and then also index these vectors or embeddings efficiently. So if I ask a question, let's say about a mountain, or if I ask a question about ocean, we have to be able to quickly retrieve these type of documents. So if I ask a question about pets, then maybe it will quickly go and find documents in the pet cluster. So that is what vector databases are supposed to do here. So it's essentially giving you vector storage plus semantic search. So when you mentioned should we yet learn another DB, it's just the extra layer of semantic search here. And why would you use a vector database as to, for example, as opposed to a relational database like PostgreSQL? Relational databases are very useful for storing structured data. So imagine you have, tabular data, first column, first name, second column, last name, something like this. It's very structured. So this is like SQL type of database. But what we want to store here is text-based documents, and how do you actually store them, and how do you retrieve them? When you ask a question, give me words that are similar to dog. That's a very vague question, and if you think about it, that's why we need a vector database. It enables us to do two things: convert the text into mathematical representation, and also enable semantic search. Again, meaning like finding information based on meaning, not just the exact words. So it understands the context behind your query and then matches it with similar ideas or similar themes. And then that is the job of the vector database for us. So, and you can use, some examples of these vector databases. There are, a lot of engines that will help. Facebook AI similarity search is one of them. Chrome DB is another one. Quadrant is another vector DB. There are a lot of examples, and what they do is, for example, they have different algorithms like inverted or inverted file or hierarchical nearest neighbor search. And there are these specialized algorithms are basically they are trained using billions of parameters, and their job is to find similar content in databases. So depending, on the application that you have. Let's say you have e-commerce, movie recommendation, you know, let's say it has like ranking requirements. These databases can be very helpful. So, yeah, so it will bring like the documents that are most relevant to the top, and then it's a, kind of like a huge win for search engines, and you can see how, different companies like Google now has this AI helper on the site. So, and there are different recommendations. So, for example, if you want to do some quick prototyping or you want to do some learning, ChromaDB is good. If you want to self-host it, maybe the Facebook model is Facebook Vector DB is good for production. Quadrant is recommended. Depending on your use case and the situation, whether it's enterprise scale or not, then there are different recommendations here. So, yeah, so we talked about, chunking, and now we stored everything. Okay, now how do we really, talk to what we build, which is basically prompting or prompt engineering. So where do we store, those embeddings? We store the embeddings in vector DB, and now we essentially have all the components that we require to assemble a RAG-based system. Now, imagine we have that. What do we do with an LLM? So essentially, we have to get the information from the vector DB. We have to concatenate it or integrate it with our prompt, and then we have to feed it to our LLM here. So, yeah, that is basically called prompt engineering. We have to make sure to prompt in a way that reduce hallucination, make sure to instruct the model. So um, we have to, get the retrieved words and then append them to user question such that, the output that the model produces is grounded in some truth, and it reduces hallucination. So that is basically kind of that's why we say prompt engineering is part art and part science. If you design prompts carefully, we provide the model with right context, right instructions, some right examples, so that it can understand our intent and align with and align the internal weights of the LLM in such a way that it's going to focus on a particular domain. So basically, the quality of the response depends on the LLM as well as the prompt. So if you give a strong prompt, you can, go quite far with if it even like a small LLM, right? So how effective, are these two prompts? So how do you even design effective prompts? So an example on what not to do. If you create a very generic prompt, like create a task, manage your app that supports collaboration. Collaboration for what? You should specifically say something like you are an agent who specializes in e-commerce domain. You seek collaboration between multiple different e-commerce partners, something around that. So users should be able to, to register or sign in, and the app should show their tasks. Tasks can be marked done or deleted. So this is, very high level prompt without any, specifically specificity associated to it, and that makes it a, if we don't have any details, it will be a very weak prompt. So Yeah, you can see different examples of, these prompts, just saying, giving generic informations. What tasks are we managing? Okay, use, for example, Firebase to connect everything. Which parts of Firebase, right? So these are, uh, there are some recommendations on how to prompt effectively. A good way, to design prompt, and that's actually there's like a whole literature on prompt engineering. So there's like whole academic papers that try to design the best prompts. They have some recommendations, and long story short, you should design prompts which provide specificity. You should design prompts which provide certain context, right? I was reading something and it said in the world of LLMs, context is king. So there are techniques like few shot prompting, chain of thought prompting, tree of thought prompting. What all these techniques do is that they provide examples to the LLM on how it should answer your question, in what style it should answer your question, what format, what length, what tone it should use. Should it be professional? Should it be friendly? Should it be informal? So prompt engineering is as much art as science. So this is very iterative process. Once you evaluate the response of an LLM, you can always tweak your prompt, you can refine your results further, and basically, fix it. So it's an iterative process, basically. All right, so now another challenge. Can a chatbot which has access only to an LLM, only a GPT type of model, not ChatGPT, only a pre-trained language model, can the chatbot answer questions like, I live in Paris, should I carry an umbrella today if I'm going out? It cannot answer this question. Why? Because it doesn't have access to external tools. ChatGPT can answer. ChatGPT can have access because it has access to weather API. So maybe it will call, the weather API and look at the weather and recommend something. But a GPT, pre-trained GPT, cannot do this. All right, so that is basically our bridge to the next step. Yeah, MCP is exactly. MCP is actually one topic that is very important in agentic AI, and that's a great, bridge. Do your prompts synonyms with requirements when compared with capturing the requirements in Um, that's actually a good, good approach. Uh, I think that's actually a great way to look at it. I think with requirements, we have if the actually working with, for example, product managers when their, requirement document, requirement gathering process is really specific, they will get a perfect answer. So kind of, yes, we have to be very patient with all this. Um, all right, so yeah, I think most questions we can answer later. Let's move to agents, which actually solve the challenge that we have. So if you just give this prompt to a pre-trained large language model, as some of you mentioned, it's not going to be able to give you a live answer. And that's where agents come in. At a very high level, an agent is nothing but an LLM plus tools, or sometimes I say agent is LLM plus action. And that is what makes them very strong, and that is what makes them insecure and requires a lot of evaluations, observability, and these are things that we will learn. An LLM in and by itself is just an LLM. But when you augment LLMs with tools, that LLM plus tool combo becomes an agent. So what is a tool? Tools can be anything. It can be Google search. It can be, a calculator app. It can be, a weather API, Slack, LinkedIn, Jira, anything and everything, right? So it can be an external database that holds memory for the LLM. So tools basically give LLM the ability to make, to augment their information and perform certain, reasoning steps. So agents essentially are, some sort of autonomous software program, and they can, carry out tasks on behalf of the user. An agent can understand, it can decide, it can execute, and it can even adapt its behavior based on the query of the user. So you can think about agents as a combination of LLM plus tools, where the LLM is the brain and the tool is like the hands and legs, the eyes, ears of the agent. So the LLM is really just the brain directing, okay, should I use brain? Should I use my ears? Which tool should I use? And then, so to kind of like carry out the analogy forward, we asked about the weather, right? Weather in Paris, should I carry an umbrella out today? The weather API is, the thing that I should be using. Is my flight today delayed? Then maybe Google Flights is the API I should be using. So tools essentially are these, different things that an LLM can decide to use to answer questions, right? Um, there are different components in agents. Some components is basically one of them is the brain of the agent, which is typically the LLM. Then we have planning, we have memory, we have tools. Memory is essentially can come in different forms. You can have external databases, you can have in context memory. Tools, as I mentioned, some of the examples of tools are a variety of different API calls. And planning at a high level is just, arranging all of these different things together. So should your agent have memory? Should your agent have tools? What tools should your agent have? And that is planning. And then we have the brain, essentially is the core LLM that will decide which tool to call when. All right. Um, right. So what all can an agent do? So agents can do because of their ability that you give an LLM to make live decisions and call these live tools. Agents can do complex tasks. They can, like, for example, find cheapest flight to Paris and then combine all of that information into a summary. They can call APIs to fetch certain live news, live stock prices, and these are, I don't even call these complex. In development world, agents are replacing on-call duties, like how much we wake up overnight over an on-call pager duty call, right? It's gone now because an agent can triage, an agent can learn the threshold of, how important the call is. Maybe it can fix it. There is co-op agents, which is, Windows-based, for example, agents. They can literally learn and track your mouse movements, and they can just, you can say, book me a flight. It can open the Chrome browser. It can search for everything, and they can generate, summarize, long paragraphs of text, right? And they can also create some actionable items based on that summary. So there are lots of things that they can do. And so, agents' way of, solving problems with an example. So if I want to, solve the previous question, I live in Paris, an umbrella problem, in an agentic way, as opposed to giving that question to just a pre-trained language model. The way to do that would be the following. An agent would take this text and identify a few things. It will identify, okay, you are talking about Paris and talking about umbrella if I'm going out. So this will get translated to, if the LLM, does its job well, it will get translated to something about the weather. So the user wants to know the weather in Paris. So the right way to do this is, let's say I have access to 100 different tools. Should I be calling calculator? Should I be calling flights or hotel? No. I should rather be calling the weather API tool to fetch the weather. That is the brain deciding. And then once I actually call that tool, let's say the weather API tool takes two things as input, the date and the city. Excuse me. So maybe, I can get the date based on the system time, and the city here is from the user's query. All right. So then we will input these things into the tool, get an HTTP response back from the API, and then based off that response, we will create an output answer. So if it is raining, then maybe the agent will respond yes. If it is not raining, it will respond no. And that is how the agent delivers the final answer. So you can see how like agents are different from LLMs, and LLM is part of an agent. So why should we use agents versus a single step LLM here? Or when should we use each? So simple LLM is useful when you have, tasks that rely on learned information. For example, what is the capital of India? It's not going to change. So, a simple LLM can do the job. Who won the World Cup in what year? In, like, for example, 1999. That answer is not going to change. So those are the types of things which are limited to training data. So a plain LLM app can do that. On the other hand, when should you use agentic AI frameworks? They are useful when you need like iterative thinking. So based on, task number one, I want to do something else. So based on, this, then call weather API, then another step, then make a recommendation. So there's a lot of steps going into this process, right? So you see how there's like different tools, real world actions, dynamic decision making, and these are all indicators that we need an agent, and a single, step LLM cannot handle this. All right, there may be some challenges with LLMs, with agents. Some of these challenges, whenever you introduce an LLM in a framework, by nature, it will be non-deterministic, it will be stochastic, and so LLMs are what they call the next token predictor, right? You know, so we can have, a cat sat on a blank. What are, the words that can go in this blank space? On a mat, on a chair, on a table. All of these are possible and quite reasonable, right? On the other hand, there are questions that need to be deterministic. What is 20 divided by 5? There's only one answer. So the challenge with agent is it comes from, this stochastic nature of LLMs, and they are trained on certain types of data. So we always say garbage in, garbage out. So if our data is bad, the LLM will be bad too. And they may have scalability, performance issues. If you're going to design a very complex agent, you have latency issues. And the more, powerful the LLM is, the more compute resources it requires. That's why, GPUs are so expensive. And if we have, a smaller LLM, you may have to design, context and prompt engineer it really, really well to make it efficient, effective. So the agents require continuous learning and maintenance. So if you're going to create, agents that require updating with new documents, updating with new systems, new databases. You will have to, set monitoring procedures, guardrails, and finally, there may be bias, training on different kind of data. There may be privacy leakage, cybersecurity concerns, compliance regulations, ethical concerns. These are all, issues that may be coming with these systems. All right. So now we have seen, what agents are, what it can do, and when to use an agent. So let's talk about some high-level building blocks associated with agents. So you have typically an agent have access to tools which enable you, to take, certain action. They need to have, some sort of planning in place. Um, which essentially that's where your prompt engineering technique is important. How should you arrange multiple agents to connect them together? And then we have memory. Should you be using external database? Do you want short-term memory? Do you want long-term memory? All of those are some of the components that you should be thinking when you design an agent. So let's talk about the building blocks. Tools API is first. All right. So again, LLM agent is LLM plus tool. So the very first thing we will talk about is tools. Maybe you want to design an agent that is very good at mathematical calculations. Then you don't need Weather API, Google Flight, etc. You just need an LLM with a very powerful calculator app. On the other hand, if you're going to design like a web search agent, then you may want web search tool and data retrieval tool. If you're going to create data insights, then maybe you may want a tool that have access to a Custo database, SQL database, be able to run SQL queries. So those are the type of tools that you should be thinking about based on your use case. And then once you have decided what the agent is going to do, and there comes, the aspect of planning and control flow. Should your agent, based system be a multi-agent system? If you're going to design a database query and update agent, maybe there should be, one agent that just formulates the SQL query. There should be another agent that takes the output, verifies the output, whether it is correct or not. And maybe there should be a third agent that coordinates these two. So there are, supervisor worker patterns. There are multiple patterns in this case. And then, we have memory and architecture. So based on your agentic framework, does having memory make sense? What kind of memory? Basically, agentic systems are like human. So there's certain level of, continuity in the conversation. For example, if you're going to keep chatting with your agent and if you have enabled short-term memory, and if you ask a question like, what is the weather? And your agent goes and says, the weather, then you will ask what are, some of the restaurants. How should the agent know that which sentence you are trying to, refer to a previous statement? Which are you still in Paris or not? Are you still talking about Paris? We are talking about weather in Paris. Are you talking about restaurant in Paris as well or not? So that's short-term memory. And it's basically dependent on how much RAM you have, how the LLM is, hosted on your local machine. And if you're going to create this, very long conversations, you may want to use, persistent storage, external databases even. You may want to have, state and checkpointing. Should your agent start, documenting these intermediate results? Is it going to be useful? For example, code reviews, right? It's needed. So if your agent is doing code review, find certain errors, maybe you should like checkpoint some of the errors and go back and solve them at a later time. And then there is observability. There are, as I said, LLMs are stochastic in nature. So you want to, see what prompt went in, what prompt went out, what was the answer produced. And you have observability frameworks like LangFuse, LangSmith are specifically designed for embedding observability. And then there are safety and guardrails. Let's not have our agents, get spammed with API calls, with rate limits, and define which questions it should answer, which questions it should not answer. Make sure that the input and the output are correctly structured, and so on. Um, or maybe, guardrails. Imagine you ask a generic question. What is, for example, the purpose of life, right? Let's say ChatGPT will give you an answer, or the LLM gives you an answer about that. But let's say, you want to design a travel agent. So you may want to design certain guardrails, either through prompt engineering or through your document or through your vector DB, where you instruct the agent to answer only those questions which are available to you. Actually, there was this recent cybersecurity attack. There's a like a small fast food, a chained fast food, Chipotle here, and they had like this conversational chatbot, and people learned that it doesn't have a limit. So instead of using ChatGPT, they were having conversations with the restaurant chatbot about any topic. And suddenly they noticed the cost of the chatbot is going crazy because people are just using it for their own purposes. So it's an interesting, era. So yeah, how AI guardrails, basically we will have guardrail at input, and we will have, guardrail in the output. So then let's talk about, agent architecture. Do we want single versus multi-agent? A single agent typically is useful when you have, one small task, but I mean, it's considered. So if one agent handles all the reasoning and all the tool calls for you, let's say, you have an email that comes every morning at 8 a.m., and then for some reason, it may contain or may not contain an invoice, and then a dollar amount that you want to pay. And so you have to extract that dollar amount, you have to put it in a CSV file, and then, some task like this, you may want to pay it, make an online payment. On the other hand, like in the case of a multi-agent workflow, are for really complex tasks. So, for example, the weather and restaurant, right? So weather is nice. I want to go out and find restaurants. If the weather is not nice, I want to list movies to watch. So I want the weather agent, I want the Netflix API call, I want some OpenTable API call, and I need to coordinate all these responses of all of these agents. They should be able to communicate with each other, and, finally, the orchestrator needs to provide a final answer to me. All right, so there are some common agent patterns. Typically, common patterns are React, stands for reasoning and action. React framework allows agents to question themselves and, their output. Whenever agent produces an output, they can go back and ask themselves, is this a correct output or not? And then there's like self-ask pattern. And finally, you have, tool formers. So essentially, these are models used to insert, certain API calls when needed. So when LLM decides, oh, it needs to call weather, it needs to call Google Flight. Those are the types of patterns that, you should keep in mind. So you need to kind of like explore, depending on your use case, which pattern to use. Um, so like just like software engineering, where we had design patterns, there's like a factory pattern, generator pattern, etc. There are patterns emerging in multi-agent frameworks as well, like planner executor pattern, where one agent plans tasks while the other executes them step by step. There is like a supervisor worker pattern, where there is one agent coordinating the workflow between all other agents. There is like swarm pattern, or there is like a delegation and handoff, where one agent does something, then that agent delegates the task to some other agent. The other agent comes back to the first agent with its output, and so on. So that's like a lot of theory, a lot of, components that we have seen. Um, and now that, we have seen like different agent framework functions, how agents think, let's shift, to talking about architecture of agents, to how we really, implement them. So when it comes to implementing agents, there are a lot of different frameworks that are made available to us to design these agents, and all of these frameworks, they abstract certain common needs. What are these common needs? Tool and function integration. So if you want to integrate all these API calls that I've been mentioning, agentic frameworks enable you to do that. They enable you to do this planning and control flow associated with your agent. They enable you to design the memory, observability, guardrail deployment, etc. So they're things that you want to worry about when you design an agentic AI system. There are frameworks that already enable you to do that, and they have, an abstracted way to implement all these concepts, right? So, what can they help you basically build? And so they can help you, design agents for, let's say, code understanding, for summarization, for chatbots, for tabular data queries, for question answers, and so on. So, and some of the popular frameworks for agentic AI development are LangChain, LangGraph. Some of them are no-code frameworks like N8N, and some are low-code frameworks like QAI. Autogen even is useful, for memory management. So yeah, you can see different frameworks. Pydantic is one of them, Autogen. And then, here's a comparison. All of these, different frameworks, they have pros and cons. So if you want something where really care about the control flow, like you want a very granular level of access to which agent should do what, maybe LangGraph is the way to go. If you have a multi-agent system, if you want, granular access and you have only one agent, maybe LangChain is enough. If you want low-code framework and you don't want to code every single aspect of your system, but you still want some amount of control, maybe QAI. If you want to rely on absolutely no code, then just do drag and drop NA8, N8N, Zapier, Make. Actually, is one of the courses that IK teach. And yeah, this is something that depending on your need, you would want to, think about. Um, so, through all of these frameworks, etc., they have the ability to integrate tools, memory, observability, etc. So it's like deciding whether I want to code in Python or do I want to code in Java or C++, etc. They all have loops. They all have if-else statements, but which one do I want to choose here? So to choose the right framework, it depends a little bit on your use case. So as I was mentioning, if you want, very fine control, if you have very complex logic, if you have single agent, something like this, then maybe LangChain is the way to go. If you have multi-agent, then LangGraph. If you have tasks that you can split to subtasks, then and you want like low code, maybe QAI or Autogen. So it really depends on what your use case is, but at the end of the day, a lot of these frameworks essentially try to do the same thing. It depends on how much granular control you want to put in when you design, these systems. So it's basically your decision here. All right. I will stop sharing, and I would like to show you an example of code here. Mm, Share. So just a little bit. Okay. So this is a LangChain agent demo. It's just a LangChain V1, just one agent, and it can decide when to call tools, when to execute them. So you will see two small tools, and you will see like an agent loop that uses those tools. You will see streaming. It's very quickly can be executed. We need, OpenAI actually, chat models. So you need LangChain and LangChain OpenAI. The first time that you run this, you need to actually install. It's a simple installation command. And then, yeah, you can check, the versions, make sure that your installation is correct, everything works fine. Um, I've seen the chat. Everyone able to see the screen? Do you need a little bit of, let me zoom in. Oh, actually too much. Okay, perfect. I see. Okay. So yeah, you can see the versions of LangChain, OpenAI, etc. You have to, so we need a brain, right? In our agentic AI, and we can use, you can use anything you like. You can even use, Hugging Face, or host the model in your own local machine, or you can use, OpenAI models, depending on which one you like, or you can use Claude models, you can use Gemini. Regardless of, what model you use, you need to provide an API key. Usually everyone with a new account have some credit to use, for example, OpenAI. After that, you can purchase the key. We recommend, not to just paste your key directly, store it in your secrets, and you can have like call it as a environment variable of your notebook. Make sure, to delete it after you used it, or give it an expiration date. Make sure to set up a threshold for it. Yeah, so basically you need to set your OpenAI key. The next step is that we need to define tools. So here the tools are basically, we want to have, we have a chatbot that helps with, refund process. So there are two tools to understand, for the agent to learn. You can create as many tools as you want. One is the policy lookup, right? Returns, a short policy snippet. We have like a policy knowledge base, right? And then there's like date between, which is basically probably for guessing, for calculating when the item is purchased and what is, today's date, how many days we have purchased, because it's a refund policy. And then the agent, which is the brain, will decide, when to call which tool. Okay, so here we have like a policy DB. It says refund. Refunds are allowed within 30 days, after 30 days, and simple JSON. And then cancellation policy, subscription can be canceled anytime, etc. So LangChain actually enables us to, like, has a tool library, and you can see, instead of us worrying about, oh, how should I implement a tool, etc., LangChain enables us to implement these tools. So we have like two tools here. One is policy lookup, and then the other one is days between. So for policy lookup, we get some sort of string, and then we look up an intellectual property here. So if the key is it cancellation or is it refund, right? It will select, which policy to return. And then for the days between, it just gets, a start date and end date, and calculate the number of days between these two, right? Then we will create the agent. So agent needs to have a model. We will use, chat OpenAI model. And then we have a create agent library. Basically, it's already wired out to all of our tools. It knows, how to call tools, etc. Very easy. So LangChain, OpenAI, and then LangChain agents. We use GPT 4.0 mini or whatever you like, whatever you have for free for your practices. You will feed it a model and then you will say temperature, sometimes depending on, if you want your agent to be very creative or if you want it to be deterministic, feed in a number for agent, how many tokens it can have, and then a timeout. So this is your LLM basically, and then an agent to you call the create agent. You pass the LLM to it. You will say which tools we call policy lookup and days between, which we actually defined here, days between and policy lookup here. And then you have some system prompts. This is very important to be, really specific in your system prompt. So you are a customer support assistant. For any policy questions, call this tool first and use only that tool text. For the days math, call days between, do not estimate. Answers exactly 2 bullet points, and if tools don't provide enough info, say what is missing here. So that is actually failure. Will there be any break? I think after my session, maybe a small break. So that is the failure mode. And then, we will run it with streaming. So you can see we have like a question. A customer purchased on this day, requested a refund on this day. Check our refund policy. Tell me if they are eligible. Use tools. Reply in exactly 2 bullet points. So then we have like an input message. Then we have, 4 chunks in the agent stream for each step, and data in the chunk items, which is basically this question will be chunked and it will get, it will be broken down to multiple steps. Then we will have different messages. Usually we don't look at these messages. This is just for the sake of the demo that we are looking at these messages. Although like now that I think about it, LLM agency mode, for example, Cloud agency, Copilot agency, they talk about what they're doing. So I guess that is basically what they're saying. They call different tools, etc. And they'll say, I'm thinking about this or I'm calling this tool, etc. So it's kind of like nice to also know what the agent is doing. But you can see first we have a tool call, which is policy lookup. Why? Because it says a customer purchased this, check our refund policy. Your brain, your agent's brain decided to first call the policy lookup, and then topic is refund here. It easily understood that they requested a refund here, and that is the call ID, call tool ID, for the sake of observability that we discussed. And then it says, so we have a task, it returns, the JSON for refund. And then there's another tool call that the agent learns, the model calls, days between, start date, end date. This is another tool call, and then it returns 22 days. And then eventually it decides 22 days, and here's the refund policy. Let me put them all together and give an answer to the customer. The customer is eligible for a refund as it is within 30 days of purchase. Next steps include processing, blah, blah. So then you can easily, grab the answer as well. If you want your agent just to give you answer, not print these sub steps, you can simply just say invoke the agent with a specific input, and then the messages part of the result is your answer here. Yeah, so this is a very small, example of how to how to build a small agent here. So I am going back to the slide to conclude the presentation here. All right, perfect. So Now, there's just some, do's and don'ts here. What should we do when, we want to build an agent, what we shouldn't do. So how would we evaluate a system? What should the agent do? We should explicitly tell the agent what tools it has access to, what tools it doesn't have access to, what should it not do, because, that is like setting up guardrails for our LLM. What should we not do? We shouldn't overcomplicate the agent with complex tasks. So whenever we design an agent, a rule of thumb is each agent should do one thing very well. You can design a complex multi-agent system, but each agent should do one thing very well. So you should not ignore, these guardrails and security controls. You should not ignore, the retry logic and error handling section. You should handle errors gracefully. For example, as I said, LLMs are stochastic systems. You should always, have a fallback mechanism if you are running out of, max iteration. If your LLM for some reason doesn't produce responses, you should have a fallback mechanism. And there are some key takeaways. So building blocks associated, with agents. We talked about tools, memory, planning, observability, safety guardrails. These are, foundations for designing robust agentic systems. Patterns, essentially React pattern, which stands for reasoning and action. It enables, self-reflection and multi-agent pattern using multi-agent frameworks. Use React pattern. They unlock very sophisticated designs for reasoning capabilities. There are multiple different frameworks like LangGraph, LangChain, Crew AI available for you to, design exactly the same thing. Um, but depending on your use case, you can choose your framework and production readiness. How complex you design your system will guide, how you're going to scale it, how you're going to monitor it, what's the infrastructure that is needed, and all of these stuff. All right, so this was the end of my session. I
Yes.
will stop sharing.
Thanks, Nayed. Thanks for taking us through, the detailed concepts. And there were so many questions coming in. I know it's a different time zone for you. You're in a US time zone and taking this session. Thanks a ton for that again. Abhinav has tried to answer most of the questions. There are obviously still some left because there were hundreds and
Mhm.
hundreds of questions that came in. But I think during the session also, you anyway answered some through them. Thanks again for joining in. Much appreciated. Uh, for people asking some questions that were coming up again and again, I'll answer them. The recording of this session, we are streaming this live on YouTube, so you will get the YouTube link. You can get in touch with your program advisor for the same, and so all the other material you can check out on the Slack and Discord community. Some people were having issues joining the Slack community, but we checked. I think just 2 minutes before that issue had come up or mentioned in the chat, people were able to join, and still I can see still people joining the Slack community. So if you want to just check something at your end, that would be helpful. Now, this is the time when we'll go to the session two. Our speaker is already in, but I'm going to take 10 minutes of yours. And why? And I'll also tell you why. Uh, when I launched the first poll, about 60% of you said that I want to layer my current role with the right Gen AI agentic AI skills. Okay, 60%. So we have thousands of participants at this point of time. And out of those, 40% said what's the biggest hurdle is the fact that they don't have a structured approach to getting those skills. So there is, and I'll while I'm saying that, I'll also go ahead share my screen. Uh, can you guys see my screen in slideshow? Just confirm that. Be helpful. Can you see my screen? Yeah. Okay. Cool. So I'll tell you. why this session, the 10 minutes, is important. Some of you can use this for a break because our program advisors will anyway talk to you. But it would be great if you just give us these 10 minutes. It would answer, because so many of you had that issue, right? I don't have a structured approach to upskilling. I want to layer my current domain with Gen AI agentic AI skills. How do I do that? We have covered, this is how we are maximizing what we are learning right now. By the way, you guys are doing all of this. So I'm not going to preach to the choir. But I have a short video of a couple of seconds from our co-founder, Ryan Wales, who has been doing this. Like I said, we are about 11, 12 years old in this is in the market. And he has over the years spoken to thousands and thousands of you and understood what is the structured approach that you guys need. So hear him out, and I'll tell you in detail right after that.
AI is no longer the future. It is here, it is the now, and it is the skill that every single person in technology needs to be on top of if you want to survive and also thrive in the next many, many, many years. This AI wave has unlocked unprecedented opportunities for all of us. If you look at all the hiring over the last few quarters, you see that all the growth has really come in AI roles, and now increasingly so in AI-enabled roles. Far more importantly, the compensation that we are seeing here, going up to $1 billion in some cases, is unheralded. It's unprecedented and nothing that we've ever seen before. We ourselves at Interview Kickstart are constantly seeing our own alumni who are AI-enabled or have AI and ML skills getting offers, and in many cases are $300,000 to $400,000 more than their peers, simply because they have the AI skill set. The challenge, though, is that AI is moving at warp speed. It's moving so fast that it's very difficult to figure out both where to start and how to pick a path that is customized, or to use a word often used these days, fine-tuned for you. That's where we at Interview Kickstart come in. We have built a career acceleration platform that helps you turbocharge your career with AI skills. We've been doing this over the last 12 years, and I've already worked with over 25,000 working professionals from all domains in tech: software, product, data, ICs, managers, and the entire like. Our approach is unique. We believe that the frontier of AI has moved to the world's best companies and the world's best AI labs, which is why we bring together a platform of over 700 instructors, all of whom come from the likes of Google, OpenAI, Meta, Anthropic, and other cutting-edge AI companies. Everything that we bring to you is designed, developed, and delivered live by these professionals. And so they bring their frontier lived experience to every single classroom. We also believe that the world has changed. It has moved from an era of passive learning to now active building. And so in each of our programs, you will get your hands dirty. You will build AI projects, all oriented on helping you build an AI portfolio, because that is what is required today if you want to turbocharge your career. Finally, we realize that there is no one-size-fits-all in AI, and AI really needs to meet you where you are at. And all of us are at different levels, have different experience, have different backgrounds. And so we offer a plethora of courses that is completely flexible. They range from 3 months, 6 months, 9 months, 12 months, spend more than a year as well, based on your career goal. They're fine-tuned for every domain. We have 18 to 20 domains that we cover. We have separate courses for ICs, separate courses for managers, and we have versions in pro code, low code, and no code. Bottom line, we want to meet you where you are and work with you step by step as you up level to building a fabulous AI career.
Yeah, so that was Ryan, I think, talking in a language and saying things that most of you would relate to. What we have typically seen amongst the thousands of learners that we deal with is that when AI started to pick up, and now 2026 is definitely going to be the year of AI, especially fronted by the technical professionals like yourself. A lot of them were in either of these four stages of AI denial, that AI is moving too fast, so I don't know where to start. There was actually one comment also in the Q&A that talked about that. Somebody said that a lot of people said that there's too much out there. I don't know how much can I grasp and how will I grasp. Some people feel that their job is too unique. Like I saw one comment in the Q&A section about, I am from cybersecurity. Do you think AI is still relevant for me? And the answer is yes, by the way, short answer. And some people feel that they'll have to down level. Most of our learners have about typically about 8 to 20 years of experience, okay? And you can't start from scratch when you have that much experience. You've already built in your expertise. AI is actually a layer that you need to add. And how can you do that is, when AI launched, this was kind of the graph. It helped in augmenting your work. So taking your productivity 10x, using LLMs, using co-pilots. That was that was the start of this era. Now we are in the 3, 4, 5 zone of this era where AI is being used to transform. So either by building complex AI agents or Gen AI apps, or by adding a layer of modern ML on your existing models, or building new models with deep ML, right? So then what are these three things? If, and you can see over here, for the first part, which is agents and Gen AI, if you want to target roles which are your domain plus AI skills, then this is where you are. You want to become an AI enabled software engineer. You want to become an AI enabled full stack engineer. Somebody was asking in the Q&A. AI enabled EM, AI enabled TPM, PM. And why am I saying all of these roles? Because our courses are available in all of these roles, right? Then comes the modern ML and deep ML part. If you want to move into AI ML intensive roles, that you want to become an MLE, you want to move into ML intensive roles, then the fourth and the fifth zone is where you are currently. We have programs for each of these three zones. So for zone 3 particularly, we have a program called Transformative Gen AI and Agentic AI plus Interview Lab, where we add a layer of Gen AI agentic AI skills in your domain. So somebody who's a tech product manager, a TPM, EM, full stack engineer, front end engineer, everybody, or data scientist, data engineer, everybody will have different paths, different learning experience, different projects that you'll do, the instructors that you'll have who will also be helping you prepare for interviews. We have 3 months of AI upskilling and 3 months of interview preparation, where in the interview preparation you get up to 15 mock interviews with the experts that are there in your domain. Who are these experts? People like Nahid, people like the next speaker, Pratik. These are the people who are part of our system, and they are helping our learners develop the right skills in their domain. Then there's something called Agentic AI Accelerator and Interview Lab. This we provide along with PwC India, in partnership with PwC India. So if you are already, you have basic to a strong understanding of AI and you just want to build your portfolio, we have some 4 case studies, enterprise level case studies that have been given by PwC India. And these are industry relevant projects, right? They have come from the industry itself. You actually build a portfolio with projects, and you scale them to a deployment level. And the program is also divided as, for example, if a problem statement comes to you from business or from your head of engineering, how will you go about it? That's how even the modules of the project is developed. This also has interview preparation as per your domain. Again, that is also customizable for 18 domains, just like in Transformative Gen AI and Agentic AI program. The last is if you want to get into ML specific roles, and I can see a lot of you are writing things in chat. I'll come back to that for sure. But I don't want to hold off the next speaker, so I'm going to finish this. So to move into ML specific roles, ML intensive roles, we have a flagship machine learning program and interview lab. That from there, that teaches you, right? That's very relevant if you want to transition into an ML role, right? So starts actually from as basic as Python, goes to classical ML, deep ML, neural networks, architecture, all of that. You have some 4 to 5 specializations over there. We also touch upon Gen AI and agentic AI concepts in that framework, in this particular program itself. Okay, so you're not just covering till about modern ML, deep ML, but also covering the Gen AI, agentic AI concepts. We have specific interview preparation that will help you prepare for these MLE roles. So if you're an SWE, if you want to move into and become a MLE, we have interview preparation specific to that. On the If you don't know where to start, right? If you want to become AI enabled, start with this. Okay, talk to the program advisor who's going to call you about this. A lot of you were asking, I'm a cybersecurity person, I'm a data engineer. I don't want to lose my expertise, but how do I become AI enabled? This is that program for you. If you are already ahead in this AI curve and you just want to build enterprise grade projects, then the PwC, in partnership with PwC India program, is for you. The timelines are written on the right hand side. The plus 3 months, plus 4 months, all of this is the interview preparation part, because we do understand that all of the skills at the end need to help you achieve the career objective that you had. Okay. And the lastly, if you want to transition into an ML role, the flagship ML and interview lab program is for you. Now, the pricing, these are the pricing. The agentic AI accelerator starts at around 2, goes up to 2.8. This is differential based on the domain preparation that you need, or for which domain do you need. Similarly, transformative Gen AI starts at 1.5, goes up till 2.8. Flagship ML starts at 3 lakh. We have some offers running at this point of time, which you can avail. There's obviously EMI options available. It comes down to, a very manageable amount per month, because all of us know that, like I said, our TG is actually our learners. The specific learners are the people who have 8+ years, 5+ years of work ex, and all of these people have responsibilities like you do. And so we understand that we have loan partners, EMI partners, all of that with us. There are some scholarships sometimes running. At this point of time, there are a few scholarships that are running. You can ask the program advisor. There's a 50% refund policy also applicable in some of these courses. Details I don't want to get into right now. The interview preparation part is what I want to touch upon quickly, is the fact that, like I said, we cover domains like software engineering, all types of software engineers separately, backend, full stack, front end, test, iOS, Android, all of these. Then you have management, in which we cover leaders like engineering managers, tech product managers, TPMs. Then we have a data domain in which we cover data engineers, data scientists, ML, AI, ML folks, all of those, or data analysts and business analysts. And lastly, we have systems domain in which we cover DevOps people, embedded software engineers, and customize the roadmap and tracks for you. Okay. Now, what do we cover in our interview preparation and career support? Let's talk about this part first. Interview preparation consists of live teaching of DSA and system design, and then we move on to domain-based interview modules. You get up to 15 mock interviews, like I said, that you can, avail. And then we also have these career services that you can see on top of the screen, which is personalized mock interviews, which I said 15 of them. These mock interviews are, by the way, with people like Nahid, Pratik, who's going to be our next speaker or speakers of tomorrow. So basically our instructors, right? So they are anyway hiring managers at their own company. So they have these 1 hour mock sessions with you where they take the interview, and then they give you verbal and written feedback also. Then we help you optimize your resume, optimize your LinkedIn, coach you for those behavior rounds, salary negotiation rounds. And we have about 200 hiring partner network where we keep sharing of successful learners who successfully complete our programs. We also keep sharing their profiles with these companies for as job referrals. So yeah, that brings me to the end of what I want to tell you about Interview Kickstart. I'm going to also launch a poll right now. Sorry, one second. Okay, I'm going to launch the poll. Yeah, I can launch the poll now. We want to know that, do you want to talk to us? Do you want assistance in the fact that uh, you want a structured approach? You want to talk to our program advisors? So tell us. We are going to get in touch with you and we are going to help you understand and build a roadmap specific to you. Okay. So I'm also going to share a calendar link of our program expert who is going to, so you can choose the slot as per your availability. So go ahead, do that and answer, the poll in front of you. Now let's get into the session 2. Some of the people would have joined us in between. So I'm just going to repeat for a couple of minutes that, guys, we have free resources that we will give out on the Slack and Discord community. I can still see some comments on the inability to log into Slack. We'll solve for that. Don't worry. We are seeing your comments. We'll solve for that. So be rest assured, just sit back and enjoy and learn from the session first. Like that's our primary goal. All of the other things we will help you out. Don't worry. We are not gating anything. So these are the free resources anyway that you'll get. Particularly, these sessions are built for engineers, product managers, technical program managers, and engineering managers. So anybody and everybody in tech. Even some of the roles are not written over here, but data engineers, if you want to talk about that, data scientists, if you want to talk about that, DevOps engineer, embedded software engineers, everybody, right? So at the end of it, you should have confidence that, hey, I can launch my AI pilot. That's what we want to achieve in these 2 days. This is not like a representation of what we do in our programs. By the way, our programs are thoroughly and fully delivered in detail. It's not as we are trying to sort of pull in everything in these 2 days and give you something to start with in your AI journey. There's not absolute representation of what we do in our programs. This we cover over weeks and weeks. Brings me to the session 2 of today, which is going to be taken by Prateek. Prateek is a software engineer at Microsoft currently. He has almost a decade of experience in tech. He moved from an engineer to a lead engineer at Samsung and then to a data engineer at Microsoft. So he has, so some of you have also, you can relate to his journey. And without further ado, I'm going to hand it over to Prateek to take this forward and tell a little about himself a little more if I didn't cover that. So thanks, Prateek, for joining in firstly, and over to you.
Thank you so much, Niyati. Thank you for introducing me. Just a second, I'm turning on my camera as well. Okay, while it comes up, yeah. Hello, everyone. Good afternoon. I am Prateek, and as Niyati already introduced me well, I have close to a decade of experience in tech. I have been working at Microsoft as a senior data engineer, but over the past I think three to 4 years now, I have been into building AI solutions and AI agents. And before Microsoft, I was working with Samsung. So by the way, I'm based out of Noida, and both of these tech companies I've worked in are in Noida. But yeah, I have been, I mean, you are in this journey right now where you're trying to, learn and make sense of what AI is. And I have been through that journey myself. Because when it came to us in like 2022 November, we were just, very in my awe, right? Wow, this tool can do so much. And then suddenly it started coding and it started, changing the entire landscape of this for us. So I'll talk about some of the things today. So let me bring up my screen and let's talk about that. Okay. Okay, I think my screen is up. Okay, cool. Yeah, so welcome everyone to the session today. Today, we are going to explore how these modern AI applications are built. My colleagues have already talked about how AI agents are being built, how they think, and how they reason. And I'm going to talk about how they interact with the tools, external tools. Okay, and this is where the power of AI actually goes beyond a single application, and it starts integrating across every other pieces that you have, and it starts doing things which, as a human, you can do. It starts interacting with tools as a human, start replicating those behaviors, and you start seeing the power of real AI is. Okay, so by the end of this session, you should be able to understand. Firstly, we'll begin with why these frameworks like LangChain and all they become popular, but what limitations that they had, what limitations developers are facing with LangChain, and how MCP and all these reasoning models are changing this entire landscape of AI development. And now, how at the end towards, we'll also see how modern system AI systems or like modern AI applications, they are connecting to tools and external data to do things beyond just that single application. Okay, so we have been like in our current usage, right? We use Instagram, we use Facebook, but all of them, they just interact within their own content. But imagine AI can actually do all of the things across multiple applications. That's where it starts behaving more like a human. Okay, so think of this today's session as moving from simply just using simple chat GPT to starting to understand how intelligence AI applications are actually being built and being used. Okay, so let me go to the next slide. Yeah. Okay, cool. So that's the agenda for today, where we will talk about, understand the fundamentals of LangChain. We'll look at the limitations. We'll explore the future with reasoning models and MCP. We'll do a hands-on session on how MCP server can be implemented and how MCP can be integrated into tools like Claude. Okay, and finally, we'll discuss how this AI development is changing itself. Okay, and we'll talk about navigating this transition in a little more depth. Okay, so now this actually mirrors how AI itself has evolved. Okay, so it's in November 2022, when ChatGPT was first launched, it started with basic prompting. But over the period of last 2 3 years, it has been more about agents, about integration with tools. Okay, so don't worry if you do not understand some of these terms. You do not need to memorize all of them. You just need to understand the idea behind what is happening here. Okay, so let's just focus on the idea first, and then we'll talk about do not worry about too much remembering all of these words. Okay. Okay, so let's first talk about LangChain, which is one of the most famous and first major framework that actually helped developers build AI applications beyond simple chatbots. Before this, frameworks like LangChain, developers, they had to manually prepare the prompt to send to these LLM APIs, handle whatever response is coming from them, manually connecting all these APIs and storing memory, and managing this entire workflow all through a lot of code that they had to do. So even to write a simple chat application or a RAG-based application, developers had to do a lot of code. Okay, which this LangChain framework simplified, and now within 4 to 5 lines, you can actually build a simple RAG application as well. Okay, so this is very similar to how web frameworks also have worked in the past, right? So React has simplified the front end development for most of us. Django or Fast API has simplified back end development, and now LangChain is simplifying this AI application development. Okay, and the key idea that the LangChain helped developers is basically it helped developer combine LLMs with databases, with APIs, with memory systems, and other tools. Okay, so this is a major shift in building your AI agents and AI applications. Okay, so let's talk about some of the important concepts in the LangChain. Okay, so again, as we mentioned, LangChain is a framework that helps you develop or build applications using large language models. And the whole intent of this was to simplify the process of building applications. Okay. Now, in this thing, framework means basically it's a set of tools, and it contains a lot of building blocks which you can just use and make your application. And large language model is for initiators, and I think we already covered this, but it's an AI model like a ChatGPT or Claude or Gemini. And you can use a framework like LangChain, combine it with large language model to build applications like chatbots or search systems or AI agents. Okay. Again, LLMs don't automatically connect, LLMs don't automatically themselves connect with the databases or read the documents or use APIs. it's not LLMs doing it. It's basically through the framework, we are able to make LLMs feed in the data coming in from various sources. Okay, so frameworks are very important in this case, and that's what helps LLM to connect to the external data sources. Okay, now let's look at the architecture of LangChain. So LangChain has few components. First is chains, which is a sequence of operations. So for example, user asks a question, then AI searches the document, and then AI summarizes the answer. So this is a chain. It's a sequence of call. Call one, get the user prompt. Call two is search the documents. Call three is AI summarizing the answer. Okay, so LangChain is used to build these chains very easily, and it has building blocks which you can just leverage and build most of the chain very simply. Then agents are basically the systems where AI decisions are being made. Okay, so instead of hard coding this, the model is choosing like what tool to use or what information to fetch or what action to perform. That's all happening within the agents. Then the memory system I had talked about. See, basically, memory systems help AI remember whatever the previous conversation has been. So without memory, LLMs, they cannot recall what you have asked previously. Okay. So we'll come to this stateless problem in the next slide. But for now, these memory systems, they are helping you and these sort of AI agents to basically remember whatever data or whatever conversation you have fed into them. Next is prompts. I think prompts you already know a lot, but it's basically a structured input which is given to these large language models, which effectively affects whatever the output the model will generate. Okay, so all modern AI applications, they combine all of these four elements together. Okay, so as you can see, you get the user prompt. This LangChain framework has things like embedding engine, vector databases, prompt engines, and all of that. So it has all of those building blocks using which you build an application. So whatever user input comes in, the AI will search any document related to that. AI will summarize the answer and then feed it back to the user. Okay, so you can do all of that through the LangChain. Okay. So see, I think by now it's already very clear that why LangChain has become important. But LangChain has basically simplified the development for users. So developers now don't need to do the entire coding, how to connect to vector databases, how to get the data, then move it from here, there, everything. Developers do not need to do that. They can just leverage the existing building blocks and build AI applications very swiftly. Plus, those applications also have additional benefits that they are more production ready rather than something that you build on your own. Okay, so it has Lego blocks like components. You could combine memory, you could combine retrieval, tools, prompts, everything you can combine and build an application. And it has a large ecosystem and a large open source community, which enables to have a lot of tools, a lot of very easy connections to multiple different tools, APIs, or vector databases, etc. Right? So it has a large ecosystem of integration among all the major tools and databases that are out there. So being the first has given it that advantage, but it also evolved very well as an open source community. Okay, that's why it's still very important. No matter the frameworks are coming in from Google. Google has Google, Microsoft. They later on release their own similar frameworks to build application like Google SDK. Then Microsoft has Microsoft Agentic AI framework or SDKs. So they are there, but then LangChain is sort of like imagine it to be. Even if Microsoft has .NET, right, you still may prefer to use Django for your application, right? So or even if there is a Spring Boot, there is still a lot of demand for other open source projects. So there will always be demand for LangChain because it being the open source, it being very popular among the industry. So that's why it has now it has become very popular, but it is also very useful. Okay, so let's look at what are some of the use cases for the LangChain. So very quickly looking at it, we can build some document analysis and QA systems where AI can read these PDFs, contracts, or whatever data you feed it in, like reports and anything, and it can answer the questions. Okay, so it's a very simple document Q&A chatbot you can build, if I'm not wrong, like in 15-20 lines of code. Okay, that's the power of LangChain. You can build data or chatbots with external knowledges. So you can ask it to connect to a search, Google search. You can, make the Google search on the fly, and then it can get the result and then answer to you. Or you can integrate it with other company data as well. Like your company may be having some data stored in some internal data systems, but you have APIs to connect to it. So you can use those API and connect it using, your LangChain framework. Then you can build automated reasoning system where you can, let's suppose, feed your problem, like whatever. Let's suppose you have a problem at I have this much number of user base, but I'm still not able to grow what could be your suggestion for the marketing campaign? Okay, these are the common things that we ask for ChatGPT and all today. They are able to give the responses because they are using the reasoning models, but you can even build your own version of how to break down step by step. Okay, so maybe you want to apply some frameworks to break down a problem, or maybe you wanted to explain using like a star framework or some other things, right? So you can customize your own chatbot, which can do this automated reasoning for you. Then you can also build an AI data extraction pipelines where you can have AI pull in the information from your structured data sources or unstructured data sources and combine them and produce, summaries, or, become a source of knowledge as well. And then lastly, and this is very, very, very important, and this is like very game changing, is where the AI can take actions on behalf of users. So AI booking meetings for you. So, so let's suppose someone is, you build a chat bot where someone messages you, and AI agent can actually look at your calendar and suggest what could be the possible meeting time, and even maybe go ahead and make booking meetings for you. So you can build those chatbots, you can build those integration within your existing tools, which will, up level your entire game. Okay, and then sending emails, tickets, everything, right? And maybe you have a Jira ticket. So this is something that we do at work as well, where instead of going to update our ADO or like Jira boards manually, what we do is we ask AI agents to do it. That okay, this is what I have done in this task. Can you update the board? So it will update the board in a proper formatted structure, right? Filling in all of the details which I have not even provided, but it has stored in its memory. Okay. Okay, so this is all great, and you would be like, oh wow, this is amazing, right? Now we don't need anything else. But there are certain limitations with this approach. Okay, let's talk about those limitations. So, for example, LangChain is all great, and it is, it helps you build a lot of applications. But then when you start building it, when you start building demos, it's very easy to do that. Okay, you can quickly build any sort of demo, right? Within days, sort of. But the real test of an application is, can it scale? Can it sustain and reliably work over the period of let's suppose a year? Okay, can it do that? Can it handle the load? That's where, as the workflows they become bigger and the chains become more complicated, it becomes harder to maintain and scale. Okay, so that's one of the limitations with LangChain frameworks. Okay, and then every tool that I'm talking about, it requires its own custom integration logic. So whatever is available from the LangChain community, it's fine. But most likely, when you are building an application in your company, you would want it to connect to your company data sources, to your company document locations, right? So there you have to build all of that integration one by one, and then those integration has to be managed independently. Okay, there is no framework within LangChain right now which can make that easy for you. There is a framework which we'll talk about, which is MCP, but yeah. Then one thing which is very, very important is stateless operations. So models, they often forget context. So unless your memory systems are like configured within your LangChain, the LLMs, they do not remember what previous conversation was or what data you have fed in. Every request that comes into the language model is like a new request. Okay, so it doesn't remember anything. It's a stateless request. Um, Let's double click once more on the scaling problem. Okay, so as you see here, I'm showing the screenshots of having Claude, Gemini, Llama, and OpenAI. These are your large language models which are available and most commonly used. But different LLMs, they use a different format to make the function calls. Okay. So when you are interacting with external tools, what LLM does is it creates a function call. Output. Okay, which the frameworks like LangChain then parse and understand and make the tool call. Okay, that's the role of the LangChain to do that. Okay, so it has to allow you to interact with different models and then different tools, which is doing it. Okay, but these different LLMs, they are making very inconsistent function calls. Inconsistent as in they have a very different structure. So as you can see here, Gemini, to make a function call, would output a JSON like this. Okay, a Gemini model would output a function like this to make a function call. Whereas OpenAI would make another different format to make the same function call. So we are using the similar functions, which is the get current stock price here in all of these, but the output produced by LLM is different in different cases. Okay, so this makes the entire building of application a little more difficult, because now you have to basically think and plan accordingly to these systems, and that results in a brittle system. Okay, if you do not, like, if you have to do for one by one for each of them, and tomorrow they change a format, OpenAI changes format, or Gemini changes format, and you are using multiple models in your application, there is a higher chance your system will go down. So okay, so that's a brittle system concept that we'll talk about now. Okay. See, these AI systems are probabilistic, right? They are returning the next token and next token and token after that based on the probability of what is the probability of next token. Basically, that's how these large language models are producing outputs. They are not doing the logical reasoning or thinking like we humans do. So that's why sometimes you see for a same question, it may output different responses, even though both of the responses may be right, because both of them, as per the training data, may have a probabilities closer to each other, but still it may not exactly produce the same output. Okay, so it's fine when you're talking in terms of chat application. You're chatting, you say something in a different sentence, you can say it in a different sentence, that is fine. English language has ambiguities. But when you are expecting these large language models to produce the function calls like we saw in the previous slide, you want your system or language model to return the perfectly formatted outputs. Okay, you do not want it to have like a missing bracket in a JSON or a missing comma in a JSON, because if you have that, and when you parse those JSON, whatever you or your framework parse that JSON to make the function call, it will fail. Okay, and your system will crash. Okay, so that sort of a brittle, that's those chains in LangChain would break when these sorts of unexpected outputs start coming from the language models. Okay, so and there is no standardized error recovery between these tools. Okay, so let's suppose maybe a tool is down or some reason, or maybe the tool itself start giving responses in a different formats, or there could be n number of things that you need to take care of when you are building systems integrating with other tools outside your control. So you will not have any standardized error recovery and error communication among these tools and your AI application. Okay, so that means each of these integration point with external tools, it requires a custom exception handling now. Okay, so you need to work with each of the system. Maybe some of the systems, maybe your team or maybe your company owns. That is fine. You can collaborate and figure out the how to handle the exception, that okay, you should always produce this output and all. But some of the tools you may be interacting, they are maybe produced owned by different companies, so you don't have much control over them, right? So you need to build this integration point with each of the different tools and handle these custom exception handling as well. Okay, so it's like building a house of cards where one unexpected input or unexpected output means everything collapses. Okay, so such brittle systems, we do not want them in production, right? So and this is in contrast with how your traditional systems have been built. Traditionally, we have built systems which are very predictable. You give them a X input, they will always produce the Y output. Okay, they have a deterministic logic. They go through step one, step two, step three, and no matter how many number of times you go through those steps, if the input is same, your output would be same. But AI systems are not like that. Okay, they are flexible. They work on probabilistic nature. They may have a non-determinism in their output. So sometimes it may output for a given input, it may output X, but on the same input, it may output Z as well. Okay. So we need to design our systems to handle all of these things. Okay. Okay. So we talked about some of the challenges like the brittleness that exists in these systems. We talked about the scaling problem. We talked about how different models produce different outputs formats, and there is a need to handle all of these things. Let's also talk about how this integration is also complicated. Okay. So developers like us, we always expect models to return structured output like JSON. Okay. But as I already mentioned, model may sometimes miss a comma, may break like a formatting, it like maybe a double quote is extra or it's missing, or overall the output is not formatted well. Okay, a JSON is not formatted well. Okay. Now, when your JSON is not formatted well, what may happen is when your parser is parsing that JSON, it would crash because it will try to parse the JSON. It will not be able to do it. It will raise an exception. It will basically, the entire call will fail. Okay. So now to solve such an issue, you would have to basically, make your own logic to, okay, this, if this is missing in a JSON, you can add this, or you can do more, parse, more specific or precise instructions for your prompt, or you can add more retries to the language model. All of that you can do to fix this issue. Okay. But there is one thing which can do all of that for you automatically, which we'll talk about as we go. Okay. Then again, there is a challenge in the reasoning layer. Okay. So for every scenario, developer need to define, if you are building applications with LangChain, right? So for every scenario, developer will need to define what tools to call, in what order, what will be the planning logic, what will be the, what will be the fallbacks in these cases, right? Now, this means that the team is spending more times connecting the systems rather than actually building an intelligent system itself, right? So now this is an important shift that we need. So earlier AI systems, they depended heavily on this, developer orchestration, where developer is doing figuring out, what should be the process, how to go from step one, then step two, then step three, and step four. But a dramatic shift has happened since we had reasoning models, where we now have started using these AI model itself to do the reasoning for us, to come up with the plan. Okay, so hey, we give this to the model that, hey, you have these many tools available to you. This is the problem that I want to solve. Can you come up with a plan? And so it says, okay, yeah, let's do that. So it comes up with a step. Okay, this is the step one you can do, and in the step one you may need to call the tool one and to get the data. Then you can do step two and step three, and then you can do tool four call to get the final output sort of. Okay, so all of this reasoning and producing a plan and what tool call to make and what fallback to happen and all of that, now LLMs can come up with that. Okay. So this is where the reasoning models, they are starting to add more like relevance to building such intelligent AI application. Okay, so no more custom logic is needed for each reasoning step. You don't need a standard approach now to plan across multiple tools. LLM or the reasoning model, they can do it. Okay, so no need to explicitly program a lot of stuff now. Where the developers used to do that, now a language model can do that well, and it can actually come up with very unique solutions which you may not have even thought about. Okay. So let's say, to double click on this reasoning example, right? So let's say you want to build an agent that helps user plan for the weather conditions. So that means you need to know the user locations, you need to know the weather conditions for that location, and then you need to provide recommendations based on that forecast that you have fetched for that location. Okay. Now, to build a simple React agent in LangChain, React means reasoning and acting. So you first reason and then you act. That's the React framework. It's not a framework as in like a LangChain framework, but it's more like a problem-solving framework, or more like a technique, or how do you build AI applications, sort of similar to how chain of thought prompting and all of those are. Okay. So, what now the LangChain basically the developer has to do in this case, they need to define and implement a custom location and weather tool classes firstly. Okay, they need to build a tool to interact and get the location of the user, another tool to get the weather tool to get the weather data. Then we need to craft a prompt with explicit reasoning instructions for each of these, and a custom output parser which will extract the model's reasoning and the chosen tools and the tool inputs, and then implement this entire agent logic with explicit reasoning that okay, in the code I have to write this. Okay, now that okay, make tool call one to get the user location. Then using this input, so now I need a parser to parse the input that I got from the previous call. Using this input, make a call to weather tool and get the weather data. Now I got the weather data, I need to parse it and make another call to, let's suppose, LLM to summarize or provide recommendation based on the forecast. And you need to program all the fallbacks and error handling for when the model that does not follow the exact expected reasoning format. Okay. Now LangChain does provide a lot of things to do it, but this interaction part, it's where it's not very strong at. Okay. Just the framework itself is not very strong. You need to basically do some other things that we will talk about next. Okay. I'm not having any visibility into the questions right now, Nidhi, but are there any questions that I should pause and take right now?
We are answering them as you talk,
Okay.
Pratik. So Abhinav is answering some of them already.
Okay, great.
Yeah.
Okay, so I'll continue talking.
Sure, you can.
Okay, thank you. Okay, now this is one of the very important problem that I have not talked about yet, just briefly mentioned, which is the stateless challenge. Okay, so all of these models, these large language models, they are stateless. Okay, so you send in a prompt, they will get you an output, but they do not now remember what did you ask first. Okay, so for example, let's suppose you ask a large language model and do not think in terms of okay, ChatGPT does it or Claude does it. ChatGPT and Claude, they are applications. They are AI applications built using models like Claude and Anthropic's Claude, or more specifically Sonnet or Opus. These are the models. Okay, and for OpenAI, GPT 4.5 and 5, these are the models. The applications that you use today, Claude and ChatGPT, those are AI applications built on top of them. So they have a lot of these things that we are talking about already implemented in them. They have memory in them. They have interactions with tool built in them, and that's how they are able to do all of that stuff. But yeah, do not think in terms of that, but the real model, the actual large language model is stateless. Okay, so let's suppose if you make an API call to the large language model and ask it, what is the capital of France? Okay, so it may return an output like okay, Paris, fine. Okay, then you ask it what is the population of that city. Now, the LLM does not know what that stands for in that, okay? Because it is stateless. It does not, it don't remember that you asked the previous question about France and its capital and all. It doesn't have any of that. So if you if you just make another API call asking what is the population in that city, it would not be able to answer because it does not know that. And in that case, it would hallucinate and give you some random number. Okay. So these things basically make you feel these AI agents are basically, sorry, the large language model, they don't have a memory for themselves. You need to create it and manage it on your application side itself. Okay. So it's like having to reintroduce yourself every time you ask a new question. That's the default behavior that large language models will give you when you ask them a question. Okay. So the current approach of doing this using the frameworks is where developer is manually managing all of this context, manually, managing the memory configuration or separate context for each of the tools, all of them, through the language, even in the language framework, we are doing it manually. But the ideal approach would be to have a unified context where state tracking is built in, where the conversation flow is continuous. Okay, where your tool output and user history, they are all managed for you. Okay, so this is the goal of having a more human-like continuity. Okay. Now let's move on to the actual thing that we are talking about, which is the future of AI is actually now very strong with the AI reasoning models and the MCP itself. So we have talked a little bit about how these will help, but we'll talk a little more in depth now. Okay. So, the AI world, we have been built previously using MCP and using, like, before the reasoning models and the MCP, the AI applications that were built, they were built mostly for hard, like using LangChain, but they were hard coded orchestration. Like I mentioned, right? A developer has to do write the code that do step one, make the tool call, then step two, then make the call. Sort of. Okay. Now we are driving it or moving towards an AI world where it's more model-driven reasoning, where model is figuring out how to do stuff, making the tool calls, and ultimately doing things more autonomously, more adaptive to the environment, adaptive to the user input. Okay, and most importantly, easier to integrate with external tools. So all of this happens with the reasoning models and MCP. Okay. So these reasoning models that we have today, they have built-in agentic capabilities. And this started with basically GPT-4o, which was first reasoning models. And then today, all of the latest models that you see, they all are reasoning models. But if you want to try a non-reasoning model, try use GPT-3 or GPT 3.5 Turbo. Those were non-reasoning models. If you use them for the same thing, like if you ask it to make a plan, give an output, JSON output, it would not do very great at it. Okay. So these reasoning models, they are moving. We are moving from through the use of these reasoning models. We are moving for more agentic capabilities, where instead of manually orchestrating the chains, we are moving to native reasoning capabilities. Like LLM is coming up with its own plan rather than us defining the workflow. Okay, or external tool selection logic is instead of us defining it, model is making the decision. Okay, what tool to pick based on the situation that it needs to do. Okay, so deciding the tool to use is done by the model. And instead of like a rigid predefined workflow, with this reasoning model plus MCP, we are moving to a world which is more flexible and adaptable in terms of interactions with the users. Okay, so this intelligent shift from a developer written workflow to a model driven workflow. Okay, so LangChain enables you to do the developer written workflow, but the LangChain with reasoning models with MCP will help you do the model driven workflows now. Okay, so LangChain is not going away. We never talked about that LangChain is bad. We talked about what is the problem if you use just LangChain, and if you don't use these reasoning models and MCP. Okay, so that's the whole theme till now. Okay, so this reasoning models, right? They have reasoning or like built-in agentic capabilities. What do we mean by that? Is basically they have think aloud capabilities. They can do step-by-step reasoning and come up with, okay, given a problem statement, they will reason step by step and come up with a solution. Or model will understand how and when to use a tool more effectively. Or and this in itself, like both the step-by-step reasoning and using the tool in the right way, effectively reduces the hallucinations a lot. It will improve the decision quality by a huge margin. Okay. And then it also supports multi-turn tool interaction. So basically, instead of doing it in a in a one shot, you can do multiple in multiple steps. You can do multiple tool calls as well. So ultimately, we are eliminating this manual orchestration loop that were required in LangChain, and now moving towards a more natural problem solving pattern, similar to how we humans work, right? We humans do not just work like a run book, like a program that, okay, given a problem, I will do step 1, step 2, step 3. But what if the problem statement has changed a bit, or maybe the input has changed a bit, or maybe now the step 3 is no longer valid? We humans figure out that, right? We humans, through our reasoning understanding, we figure out, okay, yeah, step 3 does not apply now that the input has changed. Let me take the step 4, or maybe let me do a step 3.5, or let me modify this. Now, if you were to do only the previous one, you could have like a predefined workflow which is brittle, which would not be adaptive or flexible. But using the reasoning models, you could actually make a plan according to the problem, and then giving it access to different tools through MCP, you can solve the problem end to end without a lot of a fixed logic, or a fixed workflow logic there. Okay. So this enables basically dynamic response adaptation. So modern systems, they can integrate tool outputs into more integrate in a real-time responses to the user. So instead of you can have like a streaming responses to the user. You can stream the responses as the tools are returning the output, and you can create a very natural interaction where models are reasoning about the output immediately, sort of. Okay. Then you can also, one thing which very important you can do is you can keep the contextual continuity and memory. Okay. So with this reasoning model, the context window has also expanded for most of the models. I mean, we started with what, 4K, 128K tokens, and now we have up to 1 million tokens. Okay. In some of the models. And the goal is actually to go to a 1 billion token as well. There are research and things going on. But what this enables us is to have the entire interaction history within the model's working memory itself through the session. So why? Because within the single context, since the context window has expanded, now you can feed in more information, and the model can basically, you can keep feeding in more information, and the model is able to retain that what was the reasoning going on before. So, okay. And the tool output and conversation history, they can coexist in this unified context, which will enable even more coherent reasoning across the multiple interactions. So a lot of words to unpack here, but basically what we are saying that now the model have a bigger context window. They can, in each tool calls, you can pass a lot more data. That means you can pass in the conversation history, the tool results, or the previous reasoning, everything you can pass in and get a more coherent and reasoned output. Okay. Now this is for the reasoning models and all. Now let's talk about MCP. Okay. Just a second. Okay. Okay, so now MCP is like so MCP is again an open source protocol that standardizes how applications provide context to large language models. Okay, so basically it stands for Model Context Protocol, and this is the analogy which I have read multiple times through multiple different leaders in the industry, that MCP is like USB-C standard. Like how USB-C standardized the device connections. Now we have USB-C in most our phones, and through that single port we can connect to charger, we can connect to headphones, or we can connect to maybe some camera adapter or whatever memory device, anything, right? Now that interface is standardized with the USB-C. Similar thing or similar intention is of MCP. So MCP is trying to, or it does standardize how AI systems or these large language models, they connect to things like your CRM tools or your APIs or your databases or your internal web applications. Okay, and this is the one of the most important concept that we are talking about today. Okay, MCP aims to become the universal interface for all the AI tool communication. Okay, so we have talked about why that is important, why the tool interactions can be brittle if you build it on yourself, and there is a scaling problem if you are using different models, they have different output format, and then you have to use frameworks like LangChain to handle all of that. But actually, MCP can make all of that very simple for you as a developer. It can give you a single interface to interact with these different tools. Okay, and we'll do a hands-on session. We'll look at two MCP, one which we have created, one which someone else has created. We'll try to interact with both of them through Claude. Okay. Okay. So what are the benefits of MCP? So without MCP, every integration we have to write it by our custom. And interaction means you have to write, how do you make the tool call? Okay, so for that, okay, to define that, you will make a tool in LangChain, that LangChain tool, which and define, okay, this is the API I want to call, or this is the database I want to reach, and then there is a lot of custom integration which is required there. Okay, and every model provider will have then its own output. Now you have to handle that. It's a lot complicated. That's why I talked about that house of card analogy, right? So you have making too many decisions and too many implementations, and because of that, your entire thing may not sustain as well. But MCP makes that simple. It makes using the tools simple. It makes them reusable, in fact. Okay. So it bridges the gap that the advanced models that we have today with the real world applications. Okay. So, I mean, model in itself is amazing. It's great, but it's not of much use unless it is interacting with your real world applications. That's where the MCP does. Okay. It standardizes how these applications and tool are communicating with large language models. So in effect, it is trying to create, and it has almost created a universal protocol for AI interactions with this data, with the services that we have. I mean, MCP was launched in, I think, 2024, and last year was entirely about MCP. I mean, companies have built MCP servers on top of their tools and services left and right. I mean, if within India as well, right? We had MCP from Swiggy, from Zomato, from Zerodha. So basically people have done crazy things like making a direct order from their cloud itself through this MCP. So how it happened is basically Swiggy has an MCP. You connect that with Cloud, like one of the MCPs I'll show and connect with you. You'll see that. So you can do that. You can connect and you can just use AI and that MCP and the reasoning model. These combination do a lot of stuff to interact with the real world systems. Okay. So that's the real power that people started seeing. Okay. AI can code. Oh, sorry, my screen has crashed. Just a second. I'll reshare my screen just a minute. So yeah, basically AI has in itself very powerful. These large languages are very powerful, but your when it starts interacting with the external system, that's where the real power comes in. Okay, let me bring back my screen up. Okay. Okay, so let's look at what the world before MCP looks like and what it looks like now with MCP. So before MCP, you had to create these in every application, for every application to interact with every other application, you had to create these connections yourself. So it becomes a very messy network. I mean, it looks very simple on the left because it's just one application and three tools to interact with. But imagine you had multiple applications. For each of them, you have to make their own tool interactions, and that becomes like a mess of this graph, right? Whereas now with MCP, it acts like a universal bridge. So you just build your own application. There is one MCP for each of your tool, and you just use that same MCP server for the respective tool to connect with your different applications, right? So that there is only now one protocol to follow. There is only now one, how the interaction happens. You just have to define it once in one format, and then various different applications you make, they can use the same thing. Okay, so it's very much like I actually even to explain it a little more better, MCP is a protocol we talked about. It's model context protocol. It's meant to provide context to the model. That's why it's called model context protocol. But MCP is very much like HTTP. Okay, how HTTP made communicating with any internet device easy, right? So HTTP is again a protocol, right? Hypertext transfer protocol. How did it make it simple? Basically, now both devices are speaking same languages. Okay, so this one is also the two devices on the internet, they are speaking the same language. That okay, this is how I am sending in the data packet, this is how I'm interpreting the data packet, and same thing, this person the device A also knows, and it's doing the same thing, right? So it's like both of the devices on the internet are now speaking the same language, English. Okay, MCP is very similar to that, but it's for the large language models to interact with the tools. Okay, so now instead of you defining, okay, for your application, speak English, and for your tool, okay, or maybe it's for speaking in Spanish. Now you make it, okay, yeah, I'll write another code to translate that and make it speak English so I can connect my application. But MCP simplifies that. It in itself is defining that, okay, this LLM application to interact with this tool, this is how you talk. So MCP is defining that interaction with for you for the tool. Okay, so it's like a universal bridge or universal translator, whatever you may try to call it, but in essence, it is trying to make that interaction with different tools very simple for you. Okay, and this dramatically simplifies how the development also happens for AI products. Okay, firstly, this MCP has been compatible with a lot of the frameworks that we are already have been using. So MCP does not replace anything. In fact, it is very well integrated with existing frameworks like LangChain or AutoGen or all other existing frameworks, right? So it works along with that to enable this, tool interaction. That means we are not rewriting any sort of implementations. We are preserving what we have built today, but moving forward towards a more stable and more, easy to integrate with system. Again, it simplified the development process. It standardized the tool definitions across all of the LLM providers. The first thing that we talked about in the challenge, it eliminated the need for the custom handlers for each LLM. The second thing that we talked about, right? If you are interacting with different tools in different applications, you are building your own custom integrations, you will have multiple different logics, right? But this will eliminate all of that. So it provides a very consistent behavior and it has error handling built in. Okay, so your fallback mechanism are all sort of are already there. So it makes that also very simple for us. Okay. Now, let me talk about this. Okay, so typically, so typically, if you are doing a weather planning AI assistant, as we described previously, like the user is asking, what should I wear today for my run? LLM will make the reasoning now. Okay, we talked about reasoning model, so it will make a plan. Okay, let's analyze the user query. So I'm missing the user location because they are asking me to know about sort of weather, like indirectly, right? And they are asking me what to wear for my run today. So they would need to know about the weather, whether they want a raincoat or something else, or something, warm or cool, whatever. So for that, we need user information. So LLM figured out, okay, based on the user query, we are missing user location. So let's make a tool call and get the user location. So I've got the user location is Seattle and I've saved it in my memory. Okay, now the next tool call is made to, okay, with this user location, what is the weather? So it made another tool call using MCP, get the data and store that data in the memory, and the LLM will combine this tool outputs like location, weather, and any other knowledge that is had, and to generate the recommendation. Okay, you can wear something warm or something cold depending on the weather. Okay. So so yeah, here we are making definitely multiple tool calls, and we are doing, state management and tool creation and this sequential ordering. If you were to do it like a developer reasoning chain, but if you are using reasoning models, right, with AI, let's see in the next slide how we can do it with the reasoning models and MCP. But as you see right here, we are doing multiple LM calls. We are doing this state management manually for us. Tool creation also we had to do there. But with reasoning model, this is how it would look like. I'll contrast it again for you. But again, with the reasoning models and MCP, what it will happen, you ask the same query, the LLM will figure out the location is needed, it will make the call, it will make the weather call and do the result. So first, in the first case, you had defined that, okay, this is the flow. Same flow is happening maybe for now, but you as a developer had to define that, okay, get the user location, make the weather call and all of that. In the second case, model is figuring out on itself that, model is figuring it out on itself that, okay, these are the tools calls that I need to make, or this is the information that I'm missing. And then it is making that calls and getting the recommendation. Okay. So it can produce an output that, okay, based on your location in Seattle, the weather will be 45-degree with lightweight. So for your a moisture wicking layer and a lightweight waterproof jacket is recommended. Okay. So in both of the cases, the output may be same. Okay. The final end result may be same. But in the first case, you are making the plan for the LLM. You are doing the state management. You are making all of these tool interactions happen. As a developer, you are driving this reasoning change. But in this in the second case, even the same thing is happening, right? Even in the same workflow is happening, but in your application while developing, you didn't define step 1, step 2, step 3. You just ask model or your AI agent, give it the reasoning, how to reason, and give it the access to tools via MCP, and then it reasoned in itself. Use the tools via MCP and get the result on itself. So it's doing all of that automatically for you. Sort of, okay. Same thing, like another example, if you were to ask, like, my order number is this, hasn't arrived, check what is happening and refund. Now, weather example was simple. Okay, weather one was simple. You could define, okay, if the user asking about weather, let's get its location first and then the weather, and then we'll share it, which is very fine. Okay. Now, in more complex scenarios, developer-driven and developer-written workflows will start breaking or will start, limiting in terms of its use case. So here, the question or the ask from the user is, okay, hey, my order number is this, it hasn't arrived, what is happening, refund is needed or not. In a developer workflow, you like to write, okay, step 1, check the order, step 2, do this, step 3, do this. But if you do the MCP plus the reasoning model processing, it in itself will identify that there is a need for the order status in the ask question. So let me first get the order status. Then it will analyze the return status, that whether it is delayed or whatever is the status returned based on the first tool call. Now it will make a decision that, okay, here is the thing where it's doing on its own, that it making a decision based on the status or its own reasoning, whatever you have provided it, that whether to issue a refund or not. And if it figures out, okay, issue the refund, then it does the call in itself. So all of this is happening without developer defining the workflow. Okay. So this can happen, but if you were to do it in a production system, you'd have to do a lot more things, not just directly do it, because see, you are issuing a refund, right? So you would want some human to also review whatever recommendation the model is making before actually making the money moves, right? So in a production system, you would do more things, but this shows the power of what LLM can do. But yeah, for dangerous actions like these, like issuing refund and all, you can integrate human in this loop and let them make or at least give a go ahead or thumbs up or thumbs down the issue itself. Okay. Okay. So in this case, the model can reason, okay, I have checked your order. This is the number, found it significantly delayed based on our policy. This will automatically, let me just automatically process a refund for you. So it can do that autonomous decision making and multiple tool interactions and response adaptation and all of that in a single turn without any need of developer sequence or chains. Okay. That's the power of AI reasoning models and the MCP. Okay, now move on to the hands-on implementation, where I'll show you how we can connect an MCP server. We'll talk about what that MCP server is and how we can connect it and use it to get the interactions with that tool. It's a simple tool we'll talk about. And then we could also talk about our own custom MCP if we have made, how we can interact with it. Okay, so let me get ahead from this one. And let me jump to my Claude and I'll show it to you. Okay. Let me bring in my Claude, but so I'm sure most of you have already used Claude, but Claude also has this section with, I see a lot of people not have used, which it allows you to connect with external tools. And the way it is allowing it is via MCP. And one thing that I didn't mention till now is MCP is actually the protocol that was launched or sort of authored or released by Anthropic. Anthropic is the company behind Claude. Okay, so Claude Desktop was actually the first AI application that implemented or started using MCP at a scale, and it demonstrated that so well that most of the other tools also started doing it. Okay, so let's first talk about the MCP server that we are going to mention today, and then we'll come to our own one as well. Okay, so let me zoom in actually here rather than going a full screen. I know my screen is a little big and there may be a problem reading the text. So we are looking at superdata.ai, which is a tool that allows you to do the video transcription. Okay, so you pass it in any video YouTube link, it will transcribe it for you, or you pass it in any website, it will do the web scraping for you. Okay, so using this superdata.ai, which is the tool that we're talking about, we actually open the website as well. So superdata.ai, this is the tool that we are interacting with. So using this, we can basically make any sort of, sorry, you can make the video transcription from YouTube, TikTok, Instagram, whatever. You can do the web scraping. You can extract the metadata from each of these videos. You can do all of this, and it has automated retries and rate limiting, where this retry mechanism and all of that we talked about, that as a developer you will have to do if you are interacting with the tools. Now with MCP protocol, they have like the tool or the one who's providing the MCP for their tool. They can do they can enable the automatic retries within their itself. You as a developer, you will not need to worry about it now. Okay. So to actually set this up in Claude, in your coding also you can set it, but we'll do it in the Claude Desktop app. So actually do that. Let's click this link, and it's very simple steps that we need to do. You just need to go to this connector. I have already added it. Try and see if I have another account where I can just show it to you how to do it on the fly. Okay. So let's see. Okay. So you go to the add connector. Okay. Sorry, not here. Manage connectors. Go to the manage connect plus click on the plus sign there. Manage connectors. Actually, I already have it here, but I anyways will show it to you how to do it. So click here, add custom connector, and just write the name, which is Superdata, and the remote MCP server URL. So the MCP server in this case is hosted by Supa. So you just need to give the URL to it. So this is the URL. So you'll give it the URL, click on add, then it will ask you to authorize. For that, you need to have an account to this Superdata. So it will show you a screen like, authorize to this, and then you can authorize it, and you can basically then use it. So now let's see, if let's suppose you have already authorized it and added it. What you can do is, let's give it a video and let's ask it to summarize it. Okay, so let's say I have this video on MCP. It's a short 2-minute video. I'll ask it to transcribe this YouTube video and summarize key learnings. This video is again around MCP explanation. So let's see what output we get and how does it even work. It's also okay. So it says I am not able to directly access the tools. Okay, so which is fine, because Claude should not be able to do it. But what we can do is, we have the super base now enabled here. Sorry, super data. Let's go back to the super data that we have enabled already for us. So in this account, I have super data already approved. Now let me ask the same question here, and you'll see the super data being used. Okay, so transcribe the. So in the previous case, you didn't see it transcribe because Claude. Sorry, share my screen again.
Pratik, while
Just
you
give me.
share your screen, can you keep that window a little zoomed in? Some parts.
Yeah, I'll do that. Yeah, sure.
Thanks.
I'll also bring that screen up. Actually, let me share it on smaller screen so that Okay. I think this screen text is fine, right, Niti? Or do I need to zoom in?
Yes, we can see the text here.
Okay. So in the previous case, since my previous account didn't have connection to Super Data, this one has. Now we can go plus connectors. You can see the Super Data here. Okay, this one, third one. Let's ask it to transcribe the YouTube video, share key learnings. So let's see the magic of MCP here. Okay. So you already got the transcription and the key learnings. But before going to the transcription, let's see what happened here. So if you click on this slightly grayed out text, you would see what happened here. So you would see that, the Claude loaded these tools, okay, loaded the right tool that was needed here. So the query was to transcribe the YouTube video, for which the Claude loaded three super data tools. One was the super data transcript tool, which required the URL, chunk size, and all of these inputs. And then it basically, did that function call as well. Then in the next result, you can see I'm actually making Claude actually is making the actual function call. So this is the request that it sent to the MCP server that, okay, this is the URL I want to text, and in return it got the response that, okay, whatever the entire transcript, right? And then once it has the transcript, Claude was able to summarize the key learnings. Okay, so everything happened within the single command. It reasoned first what is the tool that will be required to do this. Okay, it means the Sonnet or the Claude model here, right? So I'm using Sonnet 4.6. So Sonnet 4.6 model reason first what is the required here based on the user query. It figured out, okay, user is asking me to transcribe a video. Do I have access to tools? So it figured out, okay, I have access to a super data tool which can transcribe this video. Okay, that's how it reasoned first. Okay, then it made the call to the super data tool. Super data tool or MC via the MCP interaction, it made that function call. It make that MCP call and give the response. Once AI or the model has the response, it will again, okay, I have this transcript. Now let me figure out the key summaries as well. So it will figure out the key learnings and it will share it in this format. Okay. So end-to-end reasoning, function tool calls, everything happened within the model, within the AI application, without us, describing step one, step two, step three. So, okay. We can do something even more. I have another connector here, which is, let's see, I have Gmail. Oh, you don't have. Okay. I can also connect it with my Gmail account. Like you can go to, sorry, not to add scale. You can go to click connectors, add connector. You can add multiple connectors here. I can connect to my Gmail or the Google Drive account and get the data as well. Okay. And all of this interaction is enabled via MCP. Okay. Each of them have come up with their own MCP server that are shared, and I mean, the Anthropic has made it very simple to add it like an application sort of. But yeah, that's what has happening behind the scene. Okay, you can connect to Canva, Figma, generate visuals, generate mind map designs, everything, right? So people are doing crazy stuff with this Claude and MCP interaction because of the things that we talked about, the reasoning model and the MCP. Okay. I can also connect it with the Supabase. Supabase is it's a backend as a service. It's very similar to Google Firebase if you have used it. So you can create a new project in Supabase for my next to-do application. Okay, let's just ask it. And in this case, it will figure out, okay, to create a new project, I need access to the Supabase tool. So it's asking like a couple of details for me. Okay, I think I have. Okay, yeah, it's asking me which region to do. I said yes. Okay, let's do it in this region. Go to. Oh, it's asking for organization ID. Okay, I think I can get it. Let me get the organization ID and share my screen back. You will still see the MCP screen only, so it's fine. Okay, so Settings. Let me get my organization ID. Okay. Configure organization. This is my organization. I got my organization. Let me find its ID. Okay. Will it work? This is the org name. I don't know if it will work or not. Let's see. ID, not the name of it. Needs an ID. Okay. Anyways. Yeah, I think I need to get my ID, which I'm not able to figure out right now. But see, it was able to connect to the Superbase tool. I can show you that call. So let's see here. Okay. So it searched what tools are available that to create the Superbase project. It loaded those tools in its memory that, okay, Superbase confirm cost tool, create branch tool, or create project tool. It loaded that, and then it would have basically for create project, it needed the organization ID as a string, which I'm not able to provide it right now. But yeah, if you provide it, it will do it. So see, basically that's what MCP has made it simple for us. You can interact with any of these of tools very simply. You don't have to, define a lot of things to interact now. Now, let me also show it to you how you do it for the your own MCP as well. So let me share my screen again, the code within the desktop. Okay, so let me share. So MCP server that we have created for you. Okay. Yeah, so this is a very simple MCP server that has been created here. Let me zoom in on the text. Okay, so let's walk through this code on how to create an MCP server. You would find it very simple. For this, obviously we are using like a JSON and all of these, but the key thing here is we are using this fast MCP, which is a library again, very similar to fast API. You can use this fast MCP to create your MCP servers very quickly. In this application, I am using this Open Meteor tool to make the weather API call. So I have defined a function, helper function to make the actual tool call. So for me, it's going to be this, to make that function call, I need to define the headers and yeah, just so I'll use this one to make the actual request to the Open Meteor API. And now this is how I'm creating an MCP server just using fast MCP, and this is my server name weather. And see how easily I'll label this as a MCP tool. Okay, this basically is the call that AI can now make. Okay, so just define your function. My function is to get the weather, current weather. For this, I need to provide lat long information. Okay, and then I need to pass that to create a URL for the Open Meteor, like the base URL slash the forecast slash the lat longitude, all of these in the parameters, and along with the other parameters, and then actually make the call, get the result, and do it. Okay, this is a very simple function call that you can make, right? But what made this as an MCP server is just a simple annotation here which says MCP @mcp.tool. Now this will turn this into a function call for you. MCP call for your cloud or your AI application. Okay, and then I'm mentioning that, okay, just run this MCP server in the transport stdio. Stdio just means it's running locally on your device, so you'll use the stdi mode here. But if you were to run it on a server, you would use a different mode for that. You would probably use like a S2 server side events SSE protocol or something like that to do that. Okay, so in a very few set of lines, we are able to create our own server. Now, how do we connect this to our cloud? Again, simple stuff. We'll just go to the cloud. We'll go to the connectors, manage connectors, and so not actually not here. You just need to go to file. Is my screen share? Okay, let me share this.
Yeah, I was about to say that.
Yeah. I was limiting my screen to be fine. just go to Claude settings. Okay, and here just go to developer and then click on edit config. Okay, this will open a folder for you. This is the file Claude desktop underscore config.json. Just open this file in your text editor. This is the file it will open. And here, just write this JSON, which will describe, which will, just connect my Claude to this MCP server that I created. How? I just write the command that, okay, this is a Python program, so it will run that as a Python program. And in the argument, I just need to pass in the file path. Okay, so my file path to the server.py, I'm just passing it to that. Just this, and yeah, just close this file once you're done it, and you can, now access this in your Claude. Okay, so if I go back to my Claude in the settings, I click on, let's suppose, new chat. In the plus connectors, you would see the weather one here, which I had already added previously. But yeah, you would see it here. And if you don't see it, just quit your Claude app and restart it again, but you would see your server here. Now, let me ask it the query that, okay, what is the weather today like? And I will ask it to use my MCP server, weather MCP server. And the reason to do that is basically weather is a very simple query for Claude application in today's state. It has its own MCP and own tool integrations to get the weather data. But I want it to use my weather app or my weather MCP server. So that's why I'll ask it specifically to do that. What is the weather today like in my city? Use weather MCP connector available. Okay, so this will force it to use the MCP server that we have created. Otherwise, you would ask it a question, it would have answered without even the weather MCP server as well. Okay, so let's see it in action. Okay, so obviously it has come up with the weather details. The weather in Delhi feels like this. The temperature, humidity, it's very warm, guys. Okay, so let's see what happened behind the scenes. So the query was about weather. So it loaded the weather tool, which was the get weather. Again, this is the same that we saw on the code. Okay, and the method parameter were latitude and longitude, right? Same tool is loaded in now for the Claude to access. Okay, so and it has a description of the tool. That okay, get the weather for the location, latitude, longitude, these are the parameters. So all of this description and everything is created by that annotation that we added. So remember we added @mcp.tool and gave it a tool name. So that basically created this MCP tool. So within an MCP server, we can have multiple tools. So when I say MCP tool, it means one of the tools. We could actually have multiple methods in that file, and each of the methods can its own tool, and then you can make multiple different interactions with your API, right? So in this case, the MCP server name was weather and the tool name was get current weather. So that's why you see the name weather colon get current weather and the parameters you pass in there. And the parameters are defined like latitude, longitude, and the type. So all of this function description is very important because this function description is how LLM would know what sort of parameters or what sort of this request to make, so that it can be passed on to the MCP server, which will actually get you the result. Okay. So all of this interaction with the get weather API that I have built is handled by MCP now. The LLM only needs to figure out the right parameters and the right input for that MCP tool call. Okay, so it's a wrapper on top of your existing APIs. You can very quickly build this MCP server for any of your APIs by just adding these annotations. Okay, and see the response comes in that, okay, in the request we gave, this is the latitude or longitude, my location, whatever rough latitude, and these are the output that the weather API gave. Okay, and this is the output from the weather app that we, or the weather API that I showed, and yeah, this is the final output from the cloud. Okay, so it's that simple to connect to a MCP server. It's that simple to create your own MCP server, and that's why a lot of companies were able to do it in the last year. And still, it's now become very strong, and now people are actually building app. Like last year was mostly about building these MCP servers and all, and this year is more about building applications using these reasoning models and MCP to actually, that are actually used in different settings. Okay. I'll share my screen again for the slides, and I'll talk about the next slides. But any questions that I need to pause to for that, Niti?
Just looking at the Q&A section.
Yeah. Any broad questions do we have? I need to answer.
Somebody's asking, can you connect Kite using MCP? Yeah, I think Zerodha launched its own MCP.
Yeah, you can. I did that, but I didn't want, it specifically didn't show my question around Kite because that would reveal my own assets, right? So
Shiva asked
yeah, you
that.
can easily connect and get the data. So you can even ask it like, let's suppose that's what I do. You can ask it to connect to your Zerodha account, get your portfolio, and you can even get stock recommendation or stock suggestions or maybe stock details, right? Okay, how many holdings do I have? Does it look good on paper? Do I need to change anything? You can ask all of those questions to cloud. Obviously, you should not take that by advice like directly. You need to be cognizant about those financial advices from AI agent. But yeah, it does give some helpful advices which I have also leveraged.
Yep. Most of the questions Abhinav has been kind enough to answer. So
Thank
that
you,
you have as
Abhinav.
much time as possible for your session. So I think you can share your slides and
Yeah, I can talk about how to navigate this.
interview questions. No?
Sorry.
Sorry, I asked that I think we are now moving into the interview questions.
Yeah, we are now moving into the section where we'll talk about how to navigate this transition of how do we navigate this and how do we prepare for this transition.
Yeah, I think the screen size, is it only for me or can everybody see the screen size properly?
I can,
I think we need to
yeah, maybe you need to reshare it again.
zoom out a little bit.
Yeah. Oh, okay. Zoom out. Okay. Just a second. Reshare it.
People are saying need to zoom out. Correct. Thanks, Sujit.
Okay. Let's see. Okay, is it better now?
It's coming up. Still has that zoom out issue. So you'll just have to zoom out if in case you zoomed in earlier.
You can zoom in actually.
Yeah. 1 second.
Just see this right.
So okay for me, it's fine for me. Some people are saying so. Some people can see it. Yeah, I think let's go ahead.
Yeah, I think maybe some transient issue with Zoom, but let me share it again. Okay, let's move on and we'll see. It's not okay. Okay. So we have discussed these components, right? Chains, agent, memory systems, and output parsers. But these have previously aimed to, solve limitations that were there in earlier models. But new models, they have built-in reasoning, and that makes some of these components less important and less necessary. And most of the things, or like how you develop your AI applications, are not changing with the native capabilities that the model has, such as reasoning capabilities and MCP. Okay, so both of them together, AI reasoning models and MCP, is shifting how the earlier versions, and earlier as in sounds like way back, but it's actually not that. It's only like the way we have built application in 2023 and 2024 AI applications that has shifted now, and the focus is now more in terms of building application using these reasoning models and MCP tools rather than writing everything on your own in a brittle fashion. Okay, so currently, if you have been building AI application using LangChain, you have been orchestrating sequences of operation, you have been defining steps explicitly, and you have this rigid structure which requires updates every time something business needs a logic change or anything, right? But with advanced reasoning models and MCP, let the model handle this multi-step reasoning in itself. let it replace your explicit chains with the natural language interactions, and make more flexible and adaptable, like move towards more flexible and adaptable problem solving techniques, rather than having or thinking in that fixed mindset of I need to do this step 1, step 2, step 3. Okay. So there is a shift in mindset that as a developer we also need to make, because as developers we always try to solve the problem, and then the solution that we think is always very deterministic, that okay, this step 1, this step 2, this step 3. Okay, but that fails anytime you do it, anytime you build your application and some environment change, or some conditions change or some logic change, that code you have written needs to change, right? So that's why even this autonomous or AI agentic workflows are becoming more popular. I mean, automation is not something new, right? We have been doing automation for years and years now. But those automations, and what the difference between those automation and the today's automation, which are more AI enabled, is that previous automations had this again fixed structure, right? You do step 1, step 2, step 3. Whereas now you use LLMs to figure out a plan based on the input, based on the conditions. You ask it to come up with the plan, you ask it to come up with the steps, and it has access to tools. So it makes those tools to get either more information, and then it does everything end to end. Okay. So for example, think of it like a travel planning analogy, right? Let's suppose you have built a travel planning automator, that okay, the user just feeds in the location and it makes the everything, right? It makes the plan, it makes the booking and all. So you can do it deterministically also, that okay, whatever the user location has been given, find top 10 restaurants, or sorry, top 10 hotels, top 10 flight recommendations, pick the top one, and just make the booking, right? That's the sort of deterministic flow that we have been accustomed to. But with AI reasoning models, what it can do is, okay, let's suppose user has given more inputs, that okay, I want to go to Dubai, but with my family, I have a kid, I have this, I want only Jan food, I don't want any, I want only pure veg food. So all these sort of customization user is able to provide it at the runtime. And now the input has changed, right? So instead of you were expecting in your deterministic flow to just have, user location, user had feed in more interactions now. The user is expecting more natural language instructions, natural language interactions today, right? More users are moving from those click based to having just, able to chat. I see a lot of people, a lot of my friends, they talk a lot with Claude, right? All of us, we do. So our user behavior is also shifting towards a more natural language interaction. So next set of applications or workflows that we build, we want to have them be able to respond to how the user has asked. So if the user has asked me, okay, I'm traveling with a family, so probably the user needs a more family friendly itinerary. If they prefer only pure veg food, maybe we place them, give them a hotel where you find more pure veg food in that locality, right? So all of this adaptation AI reasoning models can do. They can reason, okay, okay, user has given these inputs. Okay, let's see this. Based on this, this becomes a more better recommendation for the hotel, a better recommendation for the flight. Maybe they're traveling with family, so they may not want to take a very early or very late night flight. They want something in middle. Okay, so all of this reasoning model is able to do, and then using the MCP, it will make the tool calls to get the details, to make the bookings and everything, right? So both together is very powerful, and it's shifting how we are building the next set of applications. Okay. Again, I think I've already mentioned this, right? Your previous agents and workflows were about, doing the reasoning, and you were defining as a developer which tools to select when. Now it is more about internal reasoning within the model, using like tool capabilities, using MCP, and then model is like selecting the right tool instead of developer deciding the tool for each use case. Okay. And then for memory systems also, this is changing. Previously, as a developer, we were uh, doing this memory management ourselves, conversation buffers, memories, all of summaries. We were storing it ourselves as developer. Now models have expanded their token or the context window. You have, a close to a million token context window, right? So model can manage its own memory. You just feed in any information you want, and model can manage its own memory. So the integration of conversation memory has become now very seamless. There is a lesser need for having external memory. At least for smaller use cases, it can work, right? For broader use cases, yeah, you may still need it. For longer term memory retention, yeah, you may still need it. But within the session of the chat window, less is needed. Okay, so more of these models have upgraded to longer context window, and that shifts how your application is also building. Okay. Then previously you had to build those custom parsers to extract the structured data and complex regex logic to do that. It was brittle, and today you have native JSON models. Okay, models are outputting JSON formats very accurately and very correctly. So you do not need to parse or validate a lot of them. They are doing much better now today in JSON parsing. That's why this MCP also came up. If the model is not able to produce a JSON correct, then MCP would not have come into the picture. It's when MCP models, LLM models started producing very good JSON. Your MCP protocol just came in and fit right there. Okay. And then we can now have direct interaction with downstream systems again through the use of MCP. Okay. So let's suppose you are building a customer support ticket resolution system. Previously, you would have to have like all of this multiple, chains, multiple components, a lot of integration, a lot of custom code. And today with AI, what you can do is you can use Cloud API with reasoning agent, and MCP tools are configured to get the data, order tool status and everything. And then, using the function calling and the tool registry, it can generate the output just the way that we saw last time. We just use one tool, but actually the Claude can actually use multiple tools depending on the user query. You could ask like a complex query, it would have done it, in multiple steps, accessing different interactions and get the result. So let's suppose I can connect it with my Gmail and my calendar and my Drive. Okay, and I can ask it, okay, based on the recent emails that I have received, schedule few calls with the email senders and whatever is and prepare a document for what to talk about in each of those meetings. So it can do all of this. It will get the emails. Based on the emails, it can figure out, okay, these are the people that we need to interact with. It can make, using Google Meet, it can make the set up the meetings for them, and can create documents based on the email interaction with that person. It can create a document about what to talk in those meetings and save it in my Google Drive. So all of that can happen in a single workflow with this reasoning models that we have and the MCP interactions. Okay, very simple tool interfaces now, and even if you had to do it in your code, you can do it very simply as well, right? You can write, you have to write a very lesser amount of code with this. Just provided the tools, just provide how you want to reason it, and very minimal integration, and you can connect with these multiple tools today. Okay, so this new AI development stack is more about advanced reasoning models, MCP for interactions, and using these using them together. So developer focus has to shift from valuable in creating valuable tools rather than thinking about how do I make call 1, call 2, call 3. That orchestration is less of a concern. Creating valuable tools is more of the value is there. Okay, then defining this tool interactions and all of that, we need not focus a lot about it now because MCP can handle most of that stuff. Okay, so how do you prepare for this transition? Firstly, you need to identify which component in your stack can be evolved or will evolve or versus it may be replaced. Okay, and then you start converting these critical tools that you have. You may have built AI applications already. You are using these tools to connect. You have built those interactions. Start converting them to MCP compatible or MCP based servers. Okay, then experiment, and I think this is something that I would encourage highly to do this after this session, is experiment with Claude and how it can interact with different tools. I mean, you would be amazed by the amount of tool interactions it can do. Obviously, very likely you will hit your Claude token limit very soon if you start, because you'll love the interaction. You'll realize what more you can do with your with Claude at your work, right? And this will simplify the complex chain, like reasoning chains. Just simplify those reasoning logic that you have done into using these advanced reasoning model capabilities to for them to do it rather than you doing that reasoning yourself. Okay, and in the long term, you need to invest in these high quality specialized tools, high quality MCP servers. You build them with automatic retries, fallback, and everything. When you're building your own MCP server, and instead of focusing more on orchestration, so build this expertise in MCP server development, focusing on data quality, retrieval performance, and everything. And yeah, prepare for a more modular and interoperable AI ecosystem, because these things they'll keep coming up, and you need to be very adaptable to all of them going forward. Okay. Okay. So we'll go to the interview section. A quick time check, Niyati. I know I'm just about time for AMA.
Yeah. So I think let's give this section about 10-15 minutes, and
Yeah.
then we can spill over a little bit and take some unanswered questions while
Okay.
we're answering most of it. Yeah.
Cool. Okay. Okay, so these are the couple of interview questions that come up, indirectly or directly. So, what are the concrete limitations of the current LangChain mechanisms? So you can answer it. I mean, you can answer it in the format that okay, it has a limit. So, firstly, whenever you are answering any interview question, what are the key points that you want to talk about? Okay, so you want to talk about the limitations of current LangChain implementation. And we talked about what we talked about scalability. We talked about integration complexity, talked about statelessness, we talked about these three things, right? So let's talk about these broad three things and now explain what each of them means to you. So limited scalability, where each of these LLM, they use inconsistent function calls format, right? From if you were to switch from OpenAI to Claude, they have different tool outputs, and then you have to build these custom handles per model. Integration is complex. You are building brittle chain, which may break anytime the output is malformed, or the brackets are missing, or there is no standardized recovery is happening, right? And then there is statelessness there, that you have to manually track the context, explicitly save whatever is given, like whatever the user asked previously, whatever the output was given, and then all of that you have to save it yourself, right? So this means developers are actually spending more of their time writing this custom interaction, custom logic, custom orchestration, rather than focusing on actual business problem. Okay. And that's where then the solution is to use the reasoning model, so that you can handle the all of these things, and reasoning model plus MCP, you can target all of these three things as we have discussed throughout this session. Okay. And don't just say that okay, LangChain is slow, or LangChain is not good, or those are the things that showcases that you do not have any in-depth understanding of the limitations. Okay, so giving very superficially responses, like high-level responses, shows that you do not have like an in-depth understanding. That's where you need to focus on more concrete answers, or like more structured responses in terms of what are the limitations here. Okay, and then should I use LangChain agent plus MCP, Claude MCP? Which when do you pick the LangChain one? Okay, so LangChain, again, it needs an explicit React loop that we need to define, whereas Claude plus MCP does all of that multi-turn reasoning on itself. LangChain would need a conversation buffer memory to save the context, whereas MCP will keep the tool outputs and history in the unified context in itself. Then LangChain would want the custom tool calls you to make them, whereas MCP will give you a standardized tool definition to use it. Okay, so the developer effort is very high when they are using just LangChain. The developer effort is quite low when they are using Claude Code, Claude plus MCP and plus reasoning model. And see, basically, you can use reasoning model and MCP within LangChain itself. But the point is, if you are not using that, then the just building these things with just the LangChain without reasoning models and MCP, we are facing all of that issues. Okay. So LangChain may still win in the cases where you want a very structured logic, or because of compliance or auditing reasoning, or you do not want you do not want LLM to make the reasoning or plan for you. You want to use just one, or maybe you are just using one model without any strong tool use case, etc. That's where LangChain may still work. But if you want to use LangChain still, use it with reasoning models, use it with MCP tools. Okay. Okay. So yeah, the floor is open for any questions. I'm happy to answer them.
Yeah, I'm just looking at the Q&A section. If the model itself has strong reasoning capabilities, why do we need a multi-agent workflow?
Good question. See, model itself has strong reasoning. It can reason, it can do all of that stuff. But when you want more complex workflows to happen, if you feed in all the information to one person, you would not be able to do it. So imagine it like this. In your team, um, uh, let's suppose there is one super smart person who can do all of that stuff, and you ask him to do everything. Okay, will that person be able to do? Probably not, right? Because not just because of the time, but because that person will be overloaded with the information. They would not know where to start, where to what to prioritize or what to focus on. Model also face similar problems. If you feed in too much context, it becomes harder for them to recall, to prioritize which one is more important task. Okay, so there are certain things that model prefer to. For example, whatever is written initially in the prompt, it would prefer to do that rather than just doing the things. So the model is just focused on like you can sorry, got a call and got distracted. So if whatever is written in the initial prompt, model will focus on that, maybe not the later on the context. Okay, if you break that into multiple agents, that makes the thing more reliable. Okay, a situation A may work sometimes. Okay, but sometimes is not a good for a production application, right? For a production application, you need reliability. You need something that happens every time, right? So for there, if you break that same workflow into multiple steps, it becomes more reliable, it becomes more manageable and maintainable. Plus, it becomes more predictable that whatever the output is coming will be right. Okay, so it can work in some cases, but in most of the cases, breaking down the problem statement into multiple agents is much more reliable. See, basically, you can limit the scope, like how you limit the scope within a team, right? That you have a PM will focus on communicating with business and getting the details and doing the requirement document. Then you have a developer who will develop it. Then you have a tester who will test it. You have broken down these things in your step, right? So you have defined their specializations, and they will focus on that. That's how the same thing with the multi-agentic framework is.
Fair. A
Okay.
lot of people don't have, I think, access to Claude working in their companies.
Ah.
Maybe because of security reason and all. And some of them are asking that can we use licensed version of Copilot to build agents because it's not allowed, or what are the alternatives? Have you come across such incidents like you were talking about, like within your community when you talk? Have there
Yeah.
been examples like this?
Yeah. Even in my company, officially, we don't have a cloud support. So whatever we have talked about using MCP server, same thing you can do with Visual Studio Code as well. So Visual Studio Code has integrated chatbot for your questions, and there also you can use MCP again to make the same calls that I'm making there. Of course, the reasoning may not be, of course, the interface may not be that great as Claude, but it can still function. You can still make the call. So that's where even I use it. I use my like MCP to interact with my task board, and then right from within my Visual Studio Code itself, right? While I'm working on it, I just open a chat window and then ask because it's connected to my task board. I ask it to update my task as well, so it can work there as well. You can do it. Copilot Premium or to create agents. Yes, you can create agents, and I think I do have access to the most premium version of Copilot, Microsoft Copilot. So I don't know how does it look like for non-premium versions, but I can create agents there, and then in that agent I can connect to the tools and define what the agent can do, and that has helped a lot in the productivity cases, right? Now, for personal productivity use cases, it helps a lot. So, like the meeting example that I was telling you about, right? So you can do that stuff using these agents that you create using the Copilot itself. Or same thing you can do in Chat GPT as well. You can create your own custom GPTs there. Again, I think you would need some premium or like paid subscription for that. So yeah, a lot of the features are actually locked behind the paid subscriptions for most of these models because they are very costly. So that's why companies are locking it down. But yeah, some free alternatives are available. Like you can use Visual Studio Code to connect to the MCP servers instead
Nice.
of Cloud Code. Yeah.
So, KK Kar has given a use case, and looking for a suggestion. So it's a little bit long. It's in the Q&A section if you want to see it, but it
Yeah,
says
yeah, let me.
we have
Yeah,
a Slack channel. So I'm just going to read it out for the audience. So we have a Slack channel where support requests are posted by dev teams for DevOps and DevOps SRE teams, such as giving additional permissions, applying Terraform PRs, asking for guidance on how to enable traces for applications, etc. We want to automate this for routine answers using supporter bot. So would Slack MCP server plus LangChain be a good choice here?
Yes, yes, absolutely. So you can use Slack MCP server to connect to the Slack tool, basically a Slack chatbot, and then it can get the details. It can write the responses there as well. Now, to define how do we handle this responses to the user, right? You would have some logic or some reasoning. For that, you can, if they are routine responses, you can maybe have a document which describes that, okay, for this question this is the response, for this question this is the response. So you can build that easily, and then I would also explore that you can define all of that in like in a markdown file, that okay, these are the instructions to these questions, and then feed that to the language model along with whatever the recent messages that you got using Slack, and then again use Slack MCP server to respond back. So you can do that, yes.
Sure. If in the Q&A section you can see one question from Hemant, I think asking about he's I think progressed a bit in his AI journey. So he has a roadmap already and is using Codex to develop this. So he's now trying to build MCP server and train it. Uh, what can you what you can suggest additional Olama, or do I need to
Okay, I think
look?
he's asking for models basically. See, I think Hemant, you're asking about which model to pick. I think the question went somewhere else.
No, I answered. I marked it
Oh,
answered.
okay.
It went
Yeah,
blank.
no worries. I found the question. Yeah. So I think you already mentioned that you have a roadmap and you're using tools and you're using Codex and everything, and you're trying to build MCP servers. And I didn't understand how you want to train it, but yeah, let's suppose you're talking about training, right? So you can use Olama. Olama is an open source model. You can run it locally. You can use Claude. You can use GPT 5.5. Those are paid. You can even use other models which are available in on Hugging Face. But see, exploring, there are thousands of models today, right? Don't just explore the models like outright, right? Explore them with a particular use case. So some models are good at some use cases. Figure out what use case you are building it for, then figure out the right model for it, then use it. Okay, rather than just exploring different models, that's what I'm assuming the intention here is. Just figure out the use case you are making it for, and then use the correct model for it. So for example, in most of the cases, Claude and GPT are able to do. But let's suppose you want something which is India focused. Okay, you want you build an India centric application with which has understanding to Indian languages. Then Claude and GPTs are okay, but Sarvam AI is better there because it has more. It has been trained on the Indian languages and it is able to respond better. So based on your use case, you need to pick the right model rather than just picking the model. So like Claude is better at writing the programming programs, right? Or more or less like today, GPT and Claude are more or less same, but let's suppose we assume it's better for now. So you use that for writing the program logic within your agent, but you use, I like responses from GPT. They are much more friendly to read. So I use GPT to summarize and finally give user the output. So within an application itself, you may use different models for different purposes and even different sizes of models. So there is a lot of complexity and a lot of understanding which is required. Not, I mean, a roadmap on a high level may help, but you also need to explore all this stuff.
Awesome. I think we have one last question, but before you answer that, I'm just going to also release the day end poll where we just want to know how was your experience, is if there is any feedback, and if you would be joining our tomorrow session. And I've also again posted the calendar link of our program expert. So if you want to know more about our programs for your domain for AI upskilling, let us know. Just go ahead, book a session as per your availability. So now again, over to you, Pratik. And while I said last question, a couple of more questions came in, but I'm going to let you answer them. So we
Yeah,
spend about 5 minutes more to just answer.
sure.
Yeah, thanks.
Thank you. So Chetan says we are using Claude in our Visual Studio Code to write our program. What kind of guardrails can we put to not expose our code bases or what we have written? Okay, so if you are using Claude, your code is already exposed in the sense that the code base is going to Claude. Okay, so and you cannot do a lot about it. If you want to protect your code base and not at all share it with Claude, then you better use local models, but they will not be as capable as the Claude and all of those models. So the code base has to go out. What you can do is certain things is never save API keys, passwords, and all of that locally on your system. Use key stores and like this cloud key stores or local key stores to save these API keys rather than saving in the code. Okay, never check in them in the code repository. I mean, that is obvious, but I still see thousands of lakhs of people actually doing it, that you have API keys checked in your GitHub repository, you pushed it the code and you think, and like, let's suppose by accidentally you do it. But if you even try to remove it, it's there in the Git history, so anyone can retrieve it, right? So yeah, it's they are just not take care of these things, not exposing your API keys and all. But yeah, your code will anyways go out if you are using this Claude code. And it's not like Claude is using that code to train. I think that's defined in the terms and conditions, but still, you'll be using it. Okay. So the next question is from Ramakrishna, which is, can I develop an AI app giving it hand to pick the right model to address the user query based on the location, culture, and genre? Yes, you can do it. You would have to give it some details on how to reason. But yes, these are known as AI routers, sort of, which basically route the request to the right model based on certain conditions. So yeah, you can build an AI application to do this. Next question, Sabah. I'm a project coordinator, so I basically look into Azure DevOps dashboard features and PBI. Great. Daily, and if I look DevOps board, it is always proper aligned, dates are updated, releases are updated, and I want to automate this process. This is a problem that even if we have solved this and track the version upgrade and other tracking using this Excel. So which tool can you use to automate the process? And there are some office policy restrictions. Okay. See, a lot of these things you can actually do within the Azure DevOps itself without even any AI tool. You can write queries, you can have a dashboard and everything. But where you can use AI is, okay, you can use again, if you don't have Claude in your company, you can use Visual Studio Code. You can connect to the ADO MCP and you can ask it to get the data, and then you can even have skills. Okay, so I didn't talk about skills, but you can explore using skills where you can define what good looks like, good updates look like. There you can define, okay, the date should be aligned, releases should be planned, and then you can just ask your the Sonnet model or whatever model you are using in Visual Studio Code that, okay, hey, are all my, or give me PBIs or which are not updated correctly. So what it will do, it will fetch the right skill, looking and get all the PBIs and compare it against whatever you have defined is good, and then it will give you the output that, okay, these are the ones which are not good, sort of. So yeah, I mean, you can do it. Just try using Cloud Code, this Visual Studio Code and MCP server for ADO and skills. This combination can help you. Okay, I think questions keep coming in. I'll try to answer three more. Okay, so
Can stop at, I think, the last question that
yeah,
has been.
I'll stop at the last one now.
Sure, sure. Thanks.
So how to create agent in GitHub? I think this question is a bit ambiguous. You can, what do you want to create? The GitHub already has an agent where you can use it to write your code and everything. You can use it to update the code within the repository. And if you want to create an agent and push it to GitHub, it's just like any other code that you do, sort of. So that's my understanding of the question. But if you can be more explicit about the question, you can answer better. Can we develop Android app using Cloud Code and ask to develop the code using the native or the React as per my choice instead of developing default technologies by React.js? Yes, you can ask it to do it. It can develop the application. You can even use it integrated in your Visual Studio or code, etc., and then it can update the existing application as well. So it can do it. You can do it in any other code, but yes, you will have to test it and verify it. Or the last one, what is the cybersecurity threat or limitation that we need to be aware of for reasoning and MCP? How should we handle such threat without sacrificing the privacy concern? This is a good question. This is the last question I want to end the session on. So yes, MCP does enable interaction with other tools, but you should not let or get all of the user's data and store it, right? Let's suppose user has, so that's why even in the current flow, you see, I authorized it, and then I can only use that super data server, right? So it's using my account only. So you need to build with the same mindset, security mindset that you have built any other applications till now. That is protecting users' privacy, limiting the data collection from the users, to avoid security threats and all. So same thing you need to apply with the reasoning and MCP server as well. Same principles, authentication you need to have, authorization you need to have. So same principles you need to keep applying and protect the user data as well. So yeah, overall, that's all I have for today. Over to you, Nidhi.
Yes, thanks a lot, Prateek. Much appreciated. Thanks for answering every question. We have answered most of it. And I'm ending my last poll also. Everybody, thanks a lot for joining in. It has been, a great last 3-4 hours now. And I hope you guys have enjoyed. Yes, recording link, Samir, there is a YouTube. This was streaming on our YouTube channel live. So the streaming link and video would be available over there. So thanks again, everyone. We'll see you tomorrow. There's a session tomorrow. So tomorrow we are going to cover 2 more topics. We are going to go deeper into this AI Launchpad. So hope to see all of you tomorrow again. Thank you, guys. Thanks, Pradeek. Bye.
Thank you so much, Nidhi. Thank you so much.